Very good evening, guys. Can you guys hear me? Let me know in the chat. Thank you, Arath, for confirming how you guys are doing. Yeah, actually, for me, today was very hectic day. A lot of production problem was happening in my system or in my server actually. So I might get call in me. Meanwhile, also might be uh, in the while I'm teaching here, I might get some messages. So I need to check that as well. So today some production issues has happened in my system, my server, and like we have followed all the things, but somehow still some steps were missing. So we are right now waiting for US team. So we have already initiated the thread there with the US team, but let's see how that goes. So yeah, it happens sometime actually when you are working in IT industries. So sometimes it happens that continuously something is not working properly, or somewhere has written some steps, or they have missed some of the steps. So you are stuck. You cannot do further things when that person is not there. So yeah, it happens. So that was the day for me today also. But let's see. We'll see. We'll wait for other people to join, and then we will start our session. So I hope you guys have practiced a lot of questions, whatever we have discussed in Stack in our last class, and I hope you guys have not faced any problem while talking about it or while implementing the logic. Have you guys implemented the Stack in JavaScript? Ekta says yes. Arad also said yes. What about others? Ankit, Nazmeen, Vishnu, Sashan. A lot of people are here. Hey, I see. I think more than 25 or 30 people joined. Daily they are joining, but in the chat I'm just seeing. Uh, I think max 9 people are only responding here. So why is that? What about other people? They are not able to follow it, or I see very less response in chat, because once you will respond only, then only I will get to know that you are able to understand the things or not. Only 10, I think max 9 people maximum they reply here in the chat, which is not good, right? So if you guys are stuck anywhere, just ask here in the comment section. Okay, guys. So this is my request to everyone, whoever is in the chat right now. Number seems fake, maybe. Okay, might be. But why would be? Why would that be fake? That's also question, right? I was creating the backend API. Someone has given me assignment. Okay. So like, see, if you're getting backend API, so I think yeah, you can give some hours to that, right? 1 hour or 1.5 hour. But right now, Ankit, you should give more of your hours to these things which we are doing in continuous classes. That would be great, right? Otherwise, you will always be behind. Today you are doing the backend API mostly, and once the backend API is done, then you will start working on Stack or linked list. At that time, we would be in we don't know in which topic. So that's why give more of your time to the current topic, and then give less, like 1 hour or 1.5 hour to the previous thing. Sometime reaction goes more than people here, so it might be fake. I have not observed this, but not sure about that. Very good evening, Najmeen. Very good evening, Nilanjan. So I hope everyone has joined. So let's talk about the last assignment question. Who has done it? Let me share my screen. So Ankit has done it. What about others? There were two questions, right? One was Ekta has also done it. There was two questions. One was like sort the stack element, and second was maximum and minimum. Find out the maximum and minimum from the stack element from the stack. So Sarath is saying he has done min and max. Okay, nice. What about others? What about like Shashan? What was the other name? Nazmeen, Nilanjan, Ankit. What about you guys? Vishnu, Suraj, Parag. A lot of people has joined. What about you guys? Have you guys solved both the problems? So Arad has done one problem. Okay. Still watching recording of last classes, unable to solve the problem. Okay. What about you, Nayan, Subhrajit? Today I solve. Okay. I did some problem linked list too, said one of them in LinkedIn group. Ah, okay, nice. Very nice. I have not seen it, but yeah, I'll see that. Okay, so I think most of you guys have done it. So let's talk about first the intuition or logic. Like first we'll visualize how the sorting will happen, and then I will also show you the code. I think once I will show you that the logic part, then I think you guys won't be needed to write the logic from my side, because the logic is very easy. So Arad is saying, can you discuss again the valid parenthesis problem? Okay, so we have similar problem today actually, which we did in the valid parenthesis. Similar problem we has today also. So we can discuss while we were discussing that problem. At that time, I can give you some of the ideas for valid parenthesis also. Okay, Rad? Similar problem we had one today again. Okay, so let's start with our problem of sorting stack. Okay, so these are the two problems. Where is it? Yeah, it's here. So sort the element of stack recursively. You should use stack methods like pop, push, and peek, and you should not create a new array but modify the existing array. So I will start like visualizing things, how the things will happen there, and then we will jump into. I will also show you the code part. Okay. By the way, if anyone has done it, want to share their idea how they have did it? Anyone who has done it? I think some people have said right. That person has done it. Who was that? Sharad has done min and max. Okay, I think nobody has replied there. What about you, Ekta? You have done it right. The sorting part. You want to share your idea quickly? What about others? Who has done the min max? Share your ideas also. Whoever has done like, yeah, sure, sure. Come on, Mike. That would be great. Yeah, it would be a little bit faster also. Yeah, please come on that. Yeah, Ekta.
Hello.
Yes, yes, we can hear you.
Yes, sir. This sorting part, it is at first I thought it would be difficult, but it was, more or less using the recursion concept. So basically,
Correct.
the most important function here is that we are using a function called insert in sorted order. So what it does is that if we have a value And if you want to insert it in a stack, so it will insert in the sorted order. So suppose we have like 3 to 1
Okay.
and we get a value 0. So it will pop all the elements, insert 0 at the bottom. So it is very similar to our insertion sort, where
Correct.
we were inserting the values at the correct position. Yes, sir. So, like, huh.
Yeah,
If
similar to that. Yes.
yes, sir. So, for me, the idea of sorting was like it would be from top of the stack 1, 2, 3, 4. In some of the examples I saw, people were like doing 4, 3, 2, 1. Like like वो ऊपर से sort करे या फिर नीचे से, that is up to us. So
Correct.
basically, if suppose if the stack is empty, we can push the incoming value as it is, because since the stack is empty and we have a single
Yes.
element, it would be in sorted order. Or
Correct.
else, if the top of the stack, suppose we have 2, 3, 4, and we get a value 1. So obviously, if either the stack is empty or the top of the stack is greater than or equal to the incoming value, we can push it. So this would be the base condition simply. So uske baad, it all boils down to this recursion and stuff. So it's this recursion actually पिछले questions पे जो हमने किए थे, it is very similar to
Correct.
that we'll take a temp, peak जो है हमारा top element, we'll take it in temp, we'll pop, and we will try to insert that like incoming data.
Correct.
Then there would be the recursion call. In the end,
Agree.
we'll push the temp. Once it has been inserted at the correct position, when it comes back from the function call, the last line would be to like push the data whatever we popped
We
it
popped out.
onto the correct position. Yes.
Correct.
So I'm not sure I have pushed it on GitHub or not. I'll just do it.
Sure, no problem. Thank you, Ekta,
Yes.
for
Thank you, sir.
explaining your answer. So that's totally correct, guys. So that's what we are also going to do it today. And we will visualize whatever Ekta was suggesting. We'll visualize the same thing today. Okay? And Nan is saying, sir, post day before yesterday's code into Git. So I think we have already pushed all the changes, Nayan, and that would be in the stack branch. Okay, Nayan? So we are still hearing you, Ekta. So let me end your call. Okay, yeah. Great. So let's start visualizing the question, guys. So let's see what was our question. Let me come back to Notepad. Yeah, OneNote. Let me first ask, you guys are able to see my screen? You guys are able to see my screen? Yes. Okay, great. So I was expecting like you guys will definitely do it, but a lot of people has not done it. Only Ekta has responded. So I'm I'm thinking like this could be the reason, because you guys are not practicing right now these days. That's why you have not done it. Otherwise, logic was very straightforward. Whatever we have done in the recursion, it's similar to that. Okay. So let's see. This is our stack. Okay. And in this stack, some elements are pushed here. Like we can say 8 first has been pushed, 1 is there, then 2 is there, then 0 is there, then 5 is there, right? And our top is it this place, right, guys? This is our stack. We all know that this is our stack, right, everyone? Okay. Now what we need to do? We need to sort this stack. We need to sort this stack, and this stack, after sorting, it should look like this. 0 should come at the bottom, then 1 minute, yeah. Yeah, then 1 should come, then 2 should come, then 5 should come, and then 8 should come. Correct, guys? That was our question, and they were asking us to use these methods like push, pop, is empty, peak, these type of methods to do that thing. Okay, to do this thing, right? So see, first thing which is coming into our mind, that we are not going to use any extra space here, like creating a new stack and then popping out those entries there, right? We can do that, right? We can create a new stack and popping out all those entries one by one there, right? That way we are not going to do that. We are going to use the recursion, because in the recursion we create the temporary memory. In the last call we have already discussed when Vishal was explaining about the auxiliary space. So that was a temporary memory which we created in stack while running our program, right? So what we do in the recursion, if you guys remember, if you want to follow the recursion here in this for this stack, how the recursion will work. So if I write the recursion method like sort stack, this is a recursion method where we have passed the stack. Okay guys, so what we were doing, if you guys remember in our last class, so we were first checking. We will call this recursion function till our stack is empty. Till our stack is empty. So when once our stack is empty, so how we will check that? Stack dot is empty. This is the method. If this method is giving us true, we will simply return from here. Or we want to like in the case of reverse, we were trying to push it from there. Or insert at bottom. If you guys remember, insert at bottom. So at that time, once our stack is empty, we were trying to insert the new element, right? Else, if our stack is not empty, what we were trying to do here, we were trying to create one temporary variable here, let temp. And in this variable, we were trying to take the peak element, right? So once we have taken this peak element, then what we were trying to do, we were trying to pop it, stack.pop. Why we were trying to do the pop? So the second top element will come. This element will be deleted. Now second element will come. Now again we will delete. This third element will be, this 2 will become top. Then this 1 will become top. Then this 8 will become top. Correct? That's how the pop was working. And then what we were doing, we were trying to call the same method, sort stack. We were trying to call the same method, right? If you guys remember this much code. And after that, for inserting the same element, what we were trying to do at the end, we were again pushing it, stack.push. And we were pushing the temp variable, temp value there. Do you guys remember this much code from our last class? Let me see in the chat. Do you guys remember this whole process? We have created one recursion tree for this. Everyone remember these lines? Anyone who has forgotten? Everyone remember, right? Yes, everyone is yes. For the reverse one also, for the reverse one we did. For the insert at bottom also we did. This is simple recursion, right? That's what we did in the last class. Okay, now guys, we will be thinking for sorting also in similar way. We are going to think about our sorting also in similar way. Okay, so let's see. Let's create the recursion method for them. So like first recursion method, sort stack. Correct. This is the first call. First time we are calling, right? First call. Now this has one temp, which is going to keep our top element, which was 5. Right, guys? Then it will call the second sort stack. Second time it will call. Then our top element will become, and the top element will be equal to temp, because you can see stack.peak, we are assigning it into temp. So next time top will become 0. Right, guys? The similar way we are creating the recursion tree there. Third time temp will become 2, and then sort stack temp will become 1, and then again sort stack will call. I hope you guys remember this recursion tree also, temp 8, and then when we call sort stack again, now our stack is empty. This return will call, and then we will go back and run the next line. There are some more lines after this, right? After this function, correct? That's what we did. I hope you guys remember this one also from last class. Everyone remember till now? Can we move further from here? Okay. Now guys, when we are at the last sort stack, when we are coming back from here to this method, at this time our temp is 8 and our method is sort stack. It means we are at we are in this place, sort stack, right? Now I will remove this line. I want to do something else after that. Once we get the temp, once we get the last element, I want to do something else. And what is it? What is it which we want to do here? We want to start inserting these elements again. We want to start inserting these elements in the stack, but we want to insert in the sorted manner now. We want to insert in the sorted manner right now. So right now, after this call, our stack is empty. Everyone agrees? Our stack is empty. Let me first come to it. Everyone agrees? After the last call, our stack is empty, right? Our main stack is empty. So now what we are going to do, guys, we are going to create one more method here. We are going to create one more method that will do the insertion part here. That will do the insertion part here. अब देखो हम डायरेक्टली इंसर्ट नहीं कर सकते हैं. हमने देखो पहली बार, चलो अगर हम वो लाइन लिखें पुरानी वाली, which is stack dot push is equal to temp, what will this line will do? It will again push 8 1 2, right guys? It will again push 8 1 2 0 5, which is not in sorted manner, right? It will just simply push normally. Yeah, that's right. It will just simply push. But we want to push it in the sorted manner. So what we are going to do, guys, we are going to create one more method which will be called after this line. After this line, and that method name would be sort, insert in sorted manner, or sorted inserted, something like that. Let's write the correct name. Something like insert in sorted manner. Insert in, I was trying to take another pen. Insert in sorted manner. Correct, guys? And in this method, pass the stack and current temp. Okay? Pass the current temp, which is 8. Pass these two things. And now we'll create the second method. We'll create a second method. And that method name is insert in sorted manner. I'm just writing in the sort form, SM. Okay? It is taking two things, stack and temp. Okay, guys? Okay, so what we have to do in this one? If our stack is empty, it means right now we do not have anything in the stack. So we can simply insert our our temp. So what would be the first condition here? If stack is empty, just insert it. There will be one more condition. I will tell you once we will come into that scenario. Because now temp 8 is coming, right? And our stack is empty. It means if there is only one element in stack, that means it's a sorted element. Guys, if there is only one element in the stack, it means that's a sorted element, right? We can only do the sorting between two elements. Everyone agrees with that? We can do only sorting between two elements. If there is only one element, it means it's already sorted. So what we'll do, we'll simply push it in the stack. So now the first line will write stack dot push that temp. Why this line will run? Because our stack is empty. So now our stack will become 8. Correct, guys? And we will return from here. Once we will return from here, this sort stack 4th would be completed. This would be completed. First this one has completed, then this one has completed. Both method has completed, right, guys? Both method has completed. Now we'll come to this one, from where the call started. 1 2, now we are at the third one, where temp is 1. Again we will be passing stack and temp. Correct, guys? We will again passing stack and temp. Correct. Now we'll come back to same method, insert in sorted manner. Now is our stack is empty? No, our stack is not empty. So now, guys, you tell me what we need to do. What we need to do here, because we need to insert the 1 here, right? We need to insert the 1 here. So 1 is smaller than our peak element or greater. So 1, whatever the next element which we want to insert, is it greater than our element? Because we want to insert in the sorted order. we want to insert in the sorted order. It means whatever element will be on the top, that should be greater. Whatever element should be in the top. You see this output which we want. You can see whatever element is the greater, that should come into the top. Okay. With the same idea, with the same intention, right now we got one. Right now we got one. So now our one is smaller than the top element. Our one is smaller than the top element. It means one has to come after 8. One has to come after 8. Right, guys? One has to come after 8. So what we'll do, we'll go into the else condition. Just wait for this condition. See, okay, let's complete first this condition. Okay, guys, let's first complete this condition. So if any element, if you say if 9 is coming here, if somebody is inserting 9, so 9, if just think about it. We have already one element in the stack, that is 8, and if somebody is inserting 9, so it has to come at the bottom or at the top. You guys tell me. In the sorted array, it has to come on the top or it has to come into the bottom. It has to come on the top. So that's why Ekta is saying bottom. No. The new element which is greater than the top, it has to come into the top. Right? The new element which is 9, which is greater than the element 8. So that's why 9 has to come onto top. So that's why this is the second condition where we will be checking stack.peak stack.peak. If stack.peak is lesser than the temp, if stack.peak is lesser than the temp, then directly push that element. So if 9 is coming, we'll directly push the 9. Okay. If 10 is coming, we'll directly push the 10. Okay. Because it is greater, right? These whatever the elements are coming, those all are greater. So if the temp are greater than stack.peak, just directly push it. So this is the second condition which I was talking about. Okay, guys. Everyone understood this second condition or both conditions? Everyone understood these both conditions? Let me know in the chat. Everyone understood both conditions? So in the first condition, if stack is empty, just insert it. Or in the second condition, whatever the top element right now in the stack, if that element is lesser than, the new element which is coming, so we want to simply push it. Okay. Okay, Nilanjan, see, this is our top element, right? In this stack, this is our top element, correct? This is our top element. So now, if next element is coming, which is greater than this, which is like 9 or 10, these numbers are greater than 8, right? So if any number which is greater than this, greater than the top element is coming, so I want to directly push them. Here. So that's what I'm writing here. If stack.peak, which means whatever element right now is at the top of the stack, if that number is lesser than the temp, I want to simply push them. So if 9 is coming, 9 will be here, 10 will be coming here. Because in the sorted manner, you can see the top element is the largest, after that it's the lowest, and then again the minimum. So like we can see we are going into decreasing order there. Understood, Nilanjan? In temp, we are giving, you can see this temp is coming from here. You can see this is the temp which we have stored while calling the sort stack. When we call the sort stack, at that time only we got the temp, right? Every new function of sort stack has a different temp. Correct? Understood? So in this temp, every sort stack has different temp, you can see. And now we are right now talking about this one, because this 2-1 has completed, second one has completed, this one is completed. Right now we are at this place, this sort stack. So after this sort stack, we are calling this one inserted in sorted method. So right now let's talk about the smaller condition. If any temp or any element which is coming, which is smaller than the top. So right now, like 1 is coming, right? Right now 1 is coming, which is smaller than the top. So what we will do, guys, here, we will pop it out. We will pop this element out because हमें result क्या चाहिए? हमें finally क्या चाहिए? What we want finally after this, we want our stack to look like this: 1 and 8. Correct, guys? So we are going to do the similar logic which we did here. We are going to do similar logic. So first we'll take the current element from stack, current top, which is 8. We'll take the current top. We'll do the current top again, stack dot peak. It will give us 8 because right now current top is 8. Correct? Then we will pop it, stack dot pop. So now our stack is again empty, right? Right now our stack is again empty, and then again we'll call this one insert in SM. Again same recursion, insert in sorted manner. Correct? And we are going to pass the same thing, stack comma the temp. Correct, guys? Correct? Insert in the s comma temp. Now what will happen? This will again come here, the same function. Now in insert in again same recursion tree for this method also. Insert in SM, stack and temp. Temp was coming 1 here, right? First time. So now we have done this thing. So temp right now, temp has become for this one. Oh, by the way, we can change this variable because 2 variables are here with the same name. So we can take this as a X. Okay, guys? So one temp is coming from the this method, right? Sort stack. So for inside the insert in sorted manner, we have taken variable name as a X. So what will be what it will look like? Now it will has this method has 2 variables now. One is temp, second one is X. Temp is storing the older value, which is 1, and X is storing now the current 8. So X will be storing the 8. And then again it is calling the insert in sorted manner. Now it is passing stack, and you can see it is still passing 1. It's still passing 1 temp. You can see we are passing 1. Correct? And when this function will be called, so you can see stack is empty. Yes, our stack is empty. And then it will push the temp variable, which will be 1. Now we'll push here 1. Correct? And then we'll return from here. We'll return from here. So this method will be completed and it will be coming back here. Now we have inserted 1 and we have our next value 8. So we can simply push it. Stack dot push X, and we can return from here. So now after 1, 8 will be pushed. That's what the similar thing will happen, guys. Let me visualize this again to you with the stack. Let me take the same example. This is the whole code only. So let me visualize this again. 8, 2, 1, 0, 5, right? This was the stack, right? So first time what will happen? Let me show you one by one step. First we'll pop 5. So pop 5. Our stack will look like this: 8, 2, 1, 0. Then we will pop 0. And you can understand these pop are temp. This pop, the values are temp. Now you can see. Now it will look like 8, 2, 1, right? Then we will pop 1. This will look like 2, 8. Then we will pop 2. It will look like 8. Then we will pop 8. Correct? And then our stack is empty. Here, this all callings are happening. These all callings are happening in first recursion method, which was sort stack. Okay. After that, we are calling the insert sorted manner. In this method, insert in sorted manner. After that, we are calling the insert in sorted manner. Correct? So now, first time the same. This method has been called. This method, this pop, we are inserting the 8. So first time we have inserted the 8. Correct? next time. Now 1 is coming. Now this sorry, this 2 is coming now. I think I have taken the wrong data, but that's fine. Now this 2 is coming. Now this 2 is coming, right? Now for this 2, first we will pop out our 8. This 8 will have internal calls. This 8 will have internal calls. First we will pop it out. This 8. First we will make this 8 empty. So we'll do pop 8. And this pop 8 we are storing in X. That's what I was showing you here. This pop we are storing in X. Now our stack is again empty. Now we will insert this temp, which is coming as 2. Temp is 2 here. Now first we'll insert 2 and then this X value 2, 8. This is internally happening inside this function only. This is the sub part of this is the sub part of this call. Now again we'll come back to this. Right now in our stack 8, 2 is there. 8, 2 is there. So now first thing what will happen, till now 8, 2 is there. So now this will make internal calls. So first 2 will be popped out. Pop 2. Then sorry, 8 would be above. Sorry. 8 would be on the top. Sorry guys, 8 and 2. Because these are in sorted manner. So now first time pop 8 will happen. Right? I'm just visualizing this thing to you guys. Then in the next call, pop 2 will happen. Pop 2 will happen. And our array will be again empty. Then guys, what will happen? Push X. Push temp, and temp is 1 here. So first we'll push temp. After pushing temp, it will look like this 1. Then we'll push this one. Push 2. 1, 2. Now this one. Push 8. Then our stack will look like this 1, 2, and 8. And now this call will be completed. This is one call. This is guys just one call. All the things are happening in this call only. These all calls. This is happening in only one function. Now this call has been completed. Now for this it will start. And again it will go for 5. And same step will happen there. I hope the visualization is helpful for you guys. Insert at bottom can be used. Yes, insert at bottom is also doing the same thing, right? Insert at bottom is also doing the same thing. So let's see. If 8 is coming, so 8 will come here, which is lesser. Okay. And 2 is coming, which is lesser. So yes, we can do the we can do the insert at bottom. 1 is coming, insert at bottom. Yes, which is doing the same thing, right? If you read the insert of bottom code, it's also doing the same thing, right? It has making the internal calls and popping it out all the elements, then inserting it back. It's also doing the same thing. Popping it out all the elements, then inserting the new one. If it Vishal is saying if it was not 1 after 2, what would happen? If it was not 1 after 2, we have already talked about, right? If the number is greater than that, we will simply push it. Okay, Vishal. If we are at the same, it will simply push. Yes, it will simply push. If the number is greater, whatever is in the top, whatever the next element is coming, if the next element is greater than the top, then we'll simply push it. We'll not do any of the popping operation there. Okay. But insert at bottom will just pop all the element and push. So I think insert at bottom we have to use this smartly. Insert at bottom we have to use this smartly, right? We have to use insert at bottom only, in those scenarios when top is lesser than, when top is greater than the newer element. When top is greater than the newer element. जब भी top बड़ा है, उस केस में हम insert at bottom चलाएंगे. In other cases, no, we won't run that. Okay. Can you explain the else part of code again? Else part of code, okay. Okay, this one, right? So see, Arad, what we are doing here, because we got some element, like you just consider this scenario, 2, 3, 5. This is our stack, and somehow we got 1, right? Somehow we got 1, which is smaller than the top element. So what we need to do here, we have to pop all the element first. We'll pop all the element first. So first we'll pop 5, then we'll pop 3, then we'll pop 2, right? First we'll do all this popping. After doing the popping, we'll first insert it. We'll insert this 1 there. So now in stack 1 is there. Then we will start going back. So 2 will be inserted, then 3 will be inserted, then 5 will be inserted. This is the visualization I am telling you, and this is the same thing happening in code. No need to remember anything, no line to you have to remember. There is nothing you have to remember. You see, first I've taken that value which I am going to pop out, which is 5. This is the line where I'm taking the value. Then I'm doing the popping. I did the popping. Now our stack has become 2, 3. Then again call the same method because our stack is not empty. You can see I again call the same method, insert in the sorted manner. And once our stack is fully empty, again same method will do the same step. Once the stack is empty, I'm just first pushing the temp variable, which is 1. You can see first we push 1, which was temp, and then 2, 3, 5. And these 2, 3, 5 are stored in X. So we are just simply pushing. Understood? So see, Likit, recursion is very easy if you know the base condition and the calling part. In the recursion only, I think 2 or 3 things are there, which I generally have seen it. In recursion, it's first the stopping condition, where our function has to stop, which is called base condition also. And then and the second thing is input. Whatever input we are going to give to recursion function. Whatever input we are going to give to recursion function, that's also very important. And third thing, how to call, but very simple. I think when I'm saying how to call, I'm talking about this part. Some people say it as a choice diagram, some people say it as a tree diagram. You can see this is the tree diagram. Some people say it as a choice diagram, some people say it as a tree diagram. So but just these are the 3 things while thinking about the recursion. Okay, so this recursion is okay. Okay, if 2 was smaller than X, we would have been popping out all elements and pushing X. Yes, that's totally right. Yes, Vishal. That's what I explained when I was explaining to Arad. In the top, there are 3 elements in the stack. You can see there are 3 elements in the top in the stack, 2, 3, 5, right? So if 1 is coming, which is already smaller, so we will pop all the elements from here. We'll pop all the elements from here till we got element which is greater, and then we will simply push it. Okay. Okay, I think recursion was first class, right? When you started the data structure. I have not taught it. Some other faculty has taught you guys, but recursion is nice topic actually. What if I had to, because I have just understood the recursion with just the drawing part. You can see the drawing part. I always understood the recursion with just the drawing. If I'm not able to draw the recursion, I'm not able to understand the recursion. Okay, Vishal is saying, Vishal, okay. What if had to add 4 in that example? If you similar thing. If you want to add the 4, 5, 3, 2, you will do the first popping 5, and then you will again call the function, and then you will see stack.peak. Is it the less than temp? You can see it's not. Stack.peak, which is 3, and your number is stack.peak, which is 3, and your number is 4. It's not. So we do not need to again do anything. We'll simply push it here. We'll simply push the 4 here, and then we will push the 5 here. Understood, Arat? You know this. We have applied 2 conditions, right? Our there is 2 base conditions, not 1. Yeah, we'll stop it there. We'll not call more time that recursion function. Hope everyone understood the logic part. Everyone understood it? Okay, now let me show you quickly the code part also. Let's see where I have implemented this one. Have I implemented or not? Yeah, it's here. I have implemented both scenarios here in this file. So you can see this is our sort stack where we are passing our stack. You can see here I am calling that sort stack. Let's just comment out this much, this time, this part of code. We'll look onto that. You can see we are calling sort stack method. We are passing our stack. The similar thing which I written there. If stack is not empty, just take the all the peak elements. Do the pop. Again call the sort stack. The sort stack loop will continuous till our stack is empty. It means this thing, the first calling, this one, sort stack. This whole calling is happening in this function. Once all the sort stack is completed, we got the return, we will call the sorted inserted. That's the next method. And here you can see in the sorted inserted, same condition. If our stack is empty or our peak is less than x or our peak is less than x, we are simply pushing it and returning it. If that's not the case, if our peak is greater, if our peak is greater than the x, then we are doing the same thing. Take the peak in temp. I have like you can see the some different variable names, but the same temp and sorted inserted s comma x, and then I'm pushing s dot push temp. Same code which I written here. The similar code is here. That's what actually. That's what actually it's very nice. Whatever we are writing while understanding these things, similar code is there. Understood? Okay, Hariharan. Okay. Here, what would be the stopping condition? Is there any other conditions? It will simply push. What would be the stopping condition for both of the loop, both of the recursion functions? You can see this is the stopping condition, right? For first one, this is the stopping condition. For the second one, sorry. For the second one, this is the stopping condition. And for first one, when our stack is empty, that is stopping condition. Understood, Hariran? For the first function, that is when stack is empty. For the second one, stack is empty and stack is empty, or sorry, or not and stack is empty, or the second one is if the top element is already smaller. Top element is already smaller than the new coming element. We will simply push it. That's the stopping condition. Hope everyone has understood it. Everyone has understood it? Let me know in the chat. What would be the time complexity of this? So for time complexity of this would be, let's see in the code. So guys, you can see all the element we are traversing here, right? First time we are traversing all the element here for the sorting slack, right? So we can say n time we are traversing already here, right? And after that, for this scenario also, I believe, I think it's n square only. It's n square. Yes, because in the worst scenario, if we see, in the second loop, we might be traversing every element every time. We might be traversing every element there also. So in worst, yes, it's n square. It's totally right. There could be like for this scenario, best complexity could be n also, because if already all the elements are sorted, then I think we will not run the second loop. If already all the elements are sorted here, we'll simply push it every time. Then this loop will not run, or this recursion function will not run. So in the best condition, it's n. In the worst condition, is n square. Understood? Understood, Parag? Yes, Likit, n square. Just too much PC that I know for sure. Time complexity. Yeah, it's n square. Short function written in stack class. Short function written in stack class. Didn't understood this question. Likit, what does it mean? Short function written in stack class. Yeah, I think the time complexity for this would be n square only. Okay. Yeah, sure. I will also push these changes so you guys can also see it. Fine, guys. Okay, you were asking sort function written in stack class. We can write it there also. We can write the sort function in stack class also. So rather than using s stack there, we will be using this, right, guys? So I think Likhit was asking, have we written this sort function in Slack class or not? So I have written it outside, but if we can write the similar thing in the inside the Slack class, Slack class also, and rather than using s or yeah, rather than using s, we must be using this dot. Okay, understood, guys? So Parag is asking how stack is useful because time complexity is always high in most of the cases. I will show you. I will show you how stack is useful. We'll talk about it. There are a lot of problems where stack is going to solve it in the what we say in the linear time. Okay, these are some of the problems which are going to be n square. Yeah, mostly we use stack in graph problems. A lot of problems actually is to use in the stack. How to pass arguments? Where? Where like we are you're saying about the passing the arguments? Try to ask full question. If we write sort in class, if you will write the sort in class, which argument you are like stuck? For which argument you are talking about? This all will be s, right? This dot pop, this dot peak, this dot sort slack. You don't need to pass s, right? In that scenario, you will just need to pass temp, right? S comma x. No need to pass s. You just need to pass x. You just need to pass x in that method. Every time that method will accept x. See, you are passing push, right? This value. This is the argument you are passing in the class. In similar way, you will pass x. Got it? No, Likit, you see the here. You are passing a value, right? In similar way, you will pass x. Got it? To every programming language we use stack to compile and run code. Yes, yes. There is always call stack is there. In every programming language, I need to check this part. But in JavaScript, I'm damn sure they have the call stack. Not sure about the other languages. I have not read their compiler structure properly. Okay, let's move quickly into the next question, guys, which is also a little bit similar. By the way, they have tried little bit. Uh, I'm not sure about you guys have seen what the reliable is suggesting. Okay, so in Java also we are using stack and the while executing the languages. Okay, so I'm not sure about that. You guys have seen the max on min code, but let's. Okay, if you guys have not seen it, that's fine. Let's talk about max min also very quickly. That's also very. That also will be very quickly solved with the recursion method only. So this is our array 8, 2, sorry, stack 3, 0, 1, right? And we need to find out max and min. Correct, guys? So what our max would be according to this stack would be 8 and min would be 0. Correct? Correct, guys? That would be our answer, max and min. Okay. Again, I think we have already done a lot of problem with recursion, with the pop and recursion. I think you guys will be very easily you guys can guess what would be the way here. So I will just give you one hint, and then you guys tell me how would we do the how would you do the same thing with the Mac? This is the push pop this method. So I will just consider my max as a peak element, and min also has a peak element. So in both scenarios it would be 1, 1. Then you guys tell me quickly what would be the way, what would be the way to find out, what would be the way to find out the max and min, or update these max and min. The better word would be how to update these max and min. Vicky has said it. What about others? Others are able to think about it. Min also. Like it compare max and min both with temp. Compare max and min both. Stack pop and compare both. Yes, totally true. We'll update the max min by comparing them with top. Comparing them with top. We can in the recursion, if you're saying about, then yes, we can do. While sort, we'll check during recursion. Yeah. Math.max, max.temp. Yes, math.min, right. Yeah, right. Definitely, that's only way. We should compare every element while recursion. Yes, I think everyone got it, right? Everyone got it right. So let's see, guys, what we'll do. We'll again do. Let's write one max min recursion function. That's the recursion function name. Max min. Correct. First time it will have temp is equal to 1. Right? Second time max min temp is equal to 0. Right? Max min temp is equal to 3. And then max min temp is equal to 2. And then max min temp is equal to 8. And once we are at the last line, we'll start comparing. If our temp is greater than max, update our max. Max is equal to temp. Else if the same temp is less than our min, we can simply update the min is equal to temp. That's what will happen. It will happen here also. The same condition will happen here also. Same condition will happen here also. Same condition will happen in the last line also. And then we will get our max min updated. That's what actually I thought. They have given some other ways, but I think because we were doing these things from the last class, so I think we would be comfortable to understand these things. Right, guys? Everyone understood? It was like we have already doing it from very bad from last class. These things we have started with insert at bottom, then we went into reverse. We did the sorting. Now we find out the max minimum with the same way. Okay, and that's what. Let me show you the code also, which I did here for max min. Same code. You see, I have taken my max as a stack.peak, min as a stack.peak, and then you can see I'm just running my stack. This stack will run. This stack. This is our base condition. This max min will be called till our stack is empty. You can see at the end I'm returning. Once our stack is empty, we are simply checking if temp is greater than max, max is equal to temp is less than min, min is equal to temp, and stack dot push. Not difficult at all. Understood, everyone? Sarah, there's one doubt, so let's see. Let's pick his doubt. Oh, okay, he has already done this. Okay, so what he has tried min is equal to this dot peak, max is equal to this dot peak. Okay, nice. So in every call, he's taking the peak. And then he has taken top also, this dot top. Okay. So I think all three will have the same data, right? Peak, top. Okay. So while top is greater than, okay. Again, you have taken the one while inside it. Okay. So you are not going with the recursion. Okay. So if while top is greater than -1, So top would be okay. Top would be -1. Okay. Top will only be happen -1 at the when the stack is empty. Okay. If this data top, okay, is greater than max, greater than max, okay, max is equal to this data top. If this data top less than min is equal to this data top, and top minus minus. Yeah, I think you are also doing the same thing, right? You are just decreasing top. You are just running one loop, and in that loop, you are just decreasing that top one by one, right? 1 minute, but you are not doing popping, right? See, okay. I understood, sir. As you have used the array approach. You have used the array approach, right? You have just reduced the index. But yeah, that's also will give you the answer. But it will not happen if you are using any other language. This code will not work if you will use Java, because in the Java you cannot reduce top directly. You have to use pop and push only to do that. Understood, sir? This will happen in Java. This will happen in JavaScript. I am actually going to talk about it. I am going to talk about it after this discussion, that how array and stack are related. And then we are in our whole class today, we are going to stop calling stack and going to use array everywhere. I'm going to talk about it. But in other languages, this will not work. Okay. Okay, so without recursion, top has index. Yes, yes, that's fine. That's fine. Sir, sorry, sir, once show your code. Sure, sure, like it. Yeah, I will also push it. Let me push it this code, guys. But yeah, if you guys want to see it, let's see that. Is it fine now? Sir, this finding min and max, will it change the stack element position? No, it won't. We are just pushing the same element. Whatever the last element is there, we are pushing the same element. It will not change. Okay. In JavaScript, I'm coming on to that one, pop and push one. So other language, don't want you to worry it. We are concerned with JS. Yeah, just popping. Okay, so everyone now okay with right? So I think time complexity would be n here, right? For finding out the min and max, right? So now, let's talk. Before jumping into the question, let's relate this stack with JavaScript. Okay, before that, I'm not sure about the in Java, but I'm going to search in front of you stack in Java. I will show you stack in Java. I have not searched it. I'm just searching it first time. You see stack class in Java. See, in the collection framework, I'm not like fully aware of the Java, but just showing you that in each, not sure about other languages also, but in other languages, they have one class, which is public class stack. And this stack will have some of the methods. Let me show you how they're using stack. Somewhere they're initializing something like that. Okay, this is the class they have created, right? No, class test is there, stack is there. Yeah, so you can see they have not created any stack class. Java already has internally stack class. See, in JavaScript, guys, we have created a stack class, right? We as a custom we are creating the stack class. But I believe, and correct me if who are already working in Java, correct me, as I can see, new stack, which is, it means it is Java which is providing the new stack. Like in the JavaScript, if you want to do array, like you do sometime new array, right? In similar way, a Java language provides the stack class, and I believe some other languages also provide the same class. And I think if we talk about the stack, I think this, you can see push and pop will also be there. push is there, pop is also there. I think the see peek is also there. These are some of the common methods which stack provides. I think search is also there. We have not implemented search, but search is also there. So why I am showing you now? Let's come back to why I am showing you. Why I am showing you? Because I am telling you all other language. I am right now taking all other languages. These are classes they have already implemented. By default, if you will install Java in your system, you will automatically get the stack collection. But in JavaScript, meanwhile, let me read something about they're saying. Yes, we just need to import a stack class in Java. Okay. Yes, I have seen some codes of Java. They already have a stack. Okay. Inbuilt methods. Yes. But in JavaScript, we do not need to do that, guys. We can perform most of the stack operation with array only. We can perform most of the, I think the most of the, I will say most of the operation with array. And let me show you how. Let me show you how. In JavaScript only. I'm not talking about everywhere. In JavaScript, let me repeat my line. In JavaScript, we can perform lot of stack operation with array only. Okay, and let me show you how very quickly. I think I know you guys already know that. Let me quickly show you. Okay, user friendly language. Developer friendly, you say, right? You want to say developer friendly, right? Okay, so see guys, I'm just taking a stack. I'm just taking one stack array. Oh, no, do not get confused. I'm just taking one array, simple array. You guys know that, right? You're working so back from the from so long. You're working in the JavaScript. That's how we create the array, right? Now, what is the first operation stack has? If you want to if you want to insert any element in the stack, what is the first method? Push. Yes, we want to insert something in the stack, use the push. JavaScript array also has the same method. If you want to push anything, you see temp dot push, and always push method will always push at the last of array. At the last of array, I want to show you one. I will push one. Let me show you temp now. You see, first element is coming. Now let's push 5. It will look like a stack only. You can see one is coming after 5. You see, you can just move this stack like this. Anti what? How much degree? 90 degree, right? You just move this stack, this array, anti-clock 90 degree. Yeah, so it will look like this. See, right now 4 5 is like this. You will just move like this, anti-clock 90 degree. So this will become like this, 4 and 5. You see, that's what the relation I'm showing you. That's the push method. Okay. Now, if you want to delete it, yeah, vertically or somebody whatever you want to say. If you want to delete it something from the stack, what method you use? Pop. Array also has the same method, and it will always delete. See, once we delete something from the stack, once we delete anything from the stack, always first element got deleted, right? Whatever in the top, that got deleted. Same thing happen in array also. Same thing happen in array also. If I do temp.pop, you guys will see. Now if I print the temp, you can see the first element which was on the top, that got deleted. That got deleted. If I again do the temp dot pop, sorry, temp dot, not comma. You can see now if you will print your temp, you will see empty stack. Understood, guys? So our array are mostly now if somebody wants to see the peak element, somebody wants to see the peak element. So let me show you that also. So let's insert very quickly again. Temp dot push is equal to 9. Let me push some more. Temp dot push is equal to 0. Okay. Temp dot push 4. Now you can see in the temp how many elements are there? 904, right? So our temp stack look like this: 9, 0, and 4, right, guys? And this is our top. And if somebody wants to take the peak element in JavaScript, This is the way we do it. Temp dot length minus 1. You will see 4 is coming at the top. Every time you will do the same line, temp dot length minus 1, you will always get the top element. Understood, guys? That's how you do the peak element. These are the important methods, right? Of stack. Everyone understood? Okay, that's what I want to tell you before jumping into that. Okay, because now I'm going to use everywhere. Whenever I will say that I'm going to use stack, I'm going to use array. Okay, wherever I'm going to use stack, wherever I'm going to say stack, I'm going to use array. Anyone will be confused? If I will say stack and array, anyone will be confused? Let me know in the right now if anyone is confused till now. Otherwise, we can move. Okay. Now we are going to do a very important question, guys, from our next slide. Yeah. Next greater element. Guys, this question I will say to everyone. I think in whole slide, I think 5 to 6 questions are there. Everywhere, the same pattern which we are going to use for this problem is going to use. The same pattern is like asked in so many problems. This is very important problem. Next greatest element. This problem comes with 4 types. Next greatest element. I think I already shared in the link list also. Sorry, in the LinkedIn. But let me repeat it. This 4 problem is going to solve a lot of hard problems also. The same pattern, whatever pattern we will learn here, that pattern is going to use a lot of problems. Okay. Next greater element, or sometimes people say that nearest element to right. Next smaller element. Sometimes people say nearest smallest nearest element nearest is element to nearest smallest element to right. Sometimes people say that nearest smallest element to left, or previous smallest element, previous greater element. These are the 4 pattern which are working in. These are the 4 different problems which are working in same pattern. And lot of problems are we are going to solve in these things like stock span, sub array minimum. I think these problems are already in the slides, and these are very good problems actually. People ask in bigger companies also these problems. And maximum area of histogram, maximum area of rectangle in binary matrix. These are the Google question actually. Maximum area of rectangle in binary matrix. This is Google question, and this is a hard question. And these are all of the questions we are going to solve with only this pattern, which we are going to talk about. So that's why everyone, please be attentive and understand this pattern. Okay. So we will start with next greater element. This is the first pattern, and this is, guys, this is definitely the problem, and we will also try to understand the pattern here. Okay. So let's see how they are explaining. I think they have also given the very nice example to understand the problem. So they are saying some people are standing in the line. Okay. Some people are standing in the line. So you can see Ganesh is in the somewhere in the line, in the middle or somewhere else. He's in the line, and tall man in front of him is obstructing his view, which irritates him. Which irritates him. Ganesh now wants to know how tall the tall person in front of him is. I think these lines could be a little bit confusing for you guys. But ऐसे समझो कि एक लाइन में 4 लोग खड़े हैं, ठीक है? बीच में कहीं गणेश है. Somewhere in the middle, Ganesh is standing. Okay. Now Ganesh is looking at one side. Might be on the right side, might be on the left side. Okay. So he wants to know who is taller than him. Who is next person who is taller than him, because the next taller person is stopping his view. He is stopping his view. क्योंकि देखो, अगर मेरे से आगे कोई बड़ा खड़ा होगा, मेरे से आगे, if somebody is standing in front of me who is taller than me, I can't see, right? I can't see the further right. I can't see the next thing, right, guys? So that's what the problem is here. We want to find out who is the next person which is greater than us, which is greater than us. Let me explain you with the array also. So see guys, okay, now we can consider this is Ganesh who is standing at this line and he wants to see at this direction. He wants to see it at this direction. You guys tell me, if his height is 5, who will be the next person who will be the next person who will be disturbing his view? Who will be the next person that person would be disturbing his view? You guys tell me in the chat. Who would be the next person who would be disturbing his view? No, no, first person, not sir, two person, second person. First person. Who would be the first person who would be disturbing his view? 7, right? Everyone agrees? Everyone agrees? For him, the next person would be 7. What about 2? What about 2? You guys tell me, what about 2? What about 2? Parag, why 5? 3 would be first person, right? Who would be disturbing his view? Right? Everyone agrees with that? 3 would be the first person. Okay. What about 1? What about 1? It would be 7, right? Same goes for 7, it would be 8. For 8, it would be nothing. It would be the next. He can see everything. He can see everything. Right guys? Same goes for 4. 8 and 4 can see everything. Understood? Understood this? So guys, our problem is we just need to find the next greater element. We just need to find next greater element. We just need to find what is the next greater element of each value in this array. That's what the question is. That's what the question is. You can see this is nothing, but we need to find the next greater element for each element. Like as you have already told, for 2 it would be 3, for 3 it would be 5, for 5 it would be 7, for 7 it would be 8, for 1 it would be 7. Understood guys? Understood everyone? Why does it seem easy? Yes, it's easy only. It's easy. Okay guys, so let's see how we will do that. How we will write. But first tell me, everyone understood the problem here? Anyone is there who is not able to understand the problem? Everyone understood, right? Totally clear? Okay, let's jump into how we will solve this problem. So first start with very like simple way, very simple way. Okay, let's start with the which we say brute force or something like starting way. Okay, let's see if you want to simply do that. So कैसे करेंगे हम लोग? हमें क्या करना है? What we need to do here? We have to stand at this position. Let's write their indexes also. 0, 1, 2, 3, 4, 5, 6. Let's stand at this position and let's traverse the whole element and find out whoever is maximum, whoever is the first maximum. So first he will find 3 here. So he will be printing the index or element, whatever you want to print. Let's take the indexes. So he will print 1. Correct? Then we will move further. Then we will move further from 2 to 3. Again, let's look for here in the remaining array. Let's look for remaining array. He will find 5. Okay. Let's post the index for that also. Let's move further. Let's go for 5. 1, no. 1 is not the smaller. 1 is not the first. 1 is not the greater. 7, yes, 7 is the greater. So let's write the index for this. 4. Let's look for 1. It would be 4 again. Right, guys? Let's look for 7. It would be 5. Right? And for 8 and 4, we can consider the whole array length. What is the whole array length? Which would be 1, 2, 3, 4, 5, 6, 7, 8. So we can say this is 8, 8. Because we do not know about the here what is happening. That's why we will just take the end of element. 8, 8. So what I want to tell you, what is happening? How will you do that here? What was happening? We were in this loop, we were at this element, and then we were traversing this whole part. Right, guys? Then we were at this place, we were traversing whole part. Right? Then we were at this place, we were traversing this whole part. Does it not look like this loop? For I is equal to 0, I less than n, I plus plus, right? For j, which start from I, j is equal to I. Let's start I from 1, right? J is equal to I, and j less than n minus 1 or something, or j plus plus. Doesn't look like this. That I will start from this 0, and then we have to look for j is equal to I or I plus 1, something like this, I plus 1, right? And then this loop will run. Right, guys? This would be the nested one, right? This would be the nested one. Okay, so Likit is saying height is equal to 5, iterate from Ganesh and find if I greater than height. Answer I, brave. Okay, if you are talking about the Ganesh only, okay. But we are looking for every element here. Okay. Are we doing it with the stack? No, I'm just simply telling it how we will do it with the for loop. This will be the nested loop, right? Sir, clear one thing for me in JavaScript, both stack and array areas exactly same. Yes, Joseph. Okay. Likit is saying not understood that 8 8. See, Likit, we are looking for next greater element. We are looking for next greater element, but we don't get any for the 8 and for 4. There is no other greater element. So that's why we have taken the last index. That's why we have taken the last index, or like wherever because this is the place, right? There is nothing. So we have to assign something, right? For these values, we have to assign something. So we can easily say that there was no greater element after this. After 8, there is no greater element. After 4, there is no greater element. So we will be identifying that with 8. Understood, Likit? Because there is no greater element for them. There is no greater index for them. Yeah, we can assign a null value also. But why we are assigning a number, it will solve a lot of problem for us. It will solve a lot of problem for us. Undefined index will not be there because the array length, we will take array length. Array length is 8. So we will take the array length here. Okay. Same for -1. If somebody is looking for the lowest element, for 2, -1 will be the lowest element. -1 index. I'm talking about index. For 2, because there is no element further to it. So we'll take -1 index for that. So we'll talk about it when we'll talk about the lesser one. But yeah, whenever we are not finding any of the element, greater or lesser, we'll take the like bound indexes, whatever the bound index is there. Okay. So why the index value are twice like 4, 4 and 8, 8? Yeah. Okay. So look for this, right? Look for this. For 5, what is the greater element here? At which index? What is the greater element? It's at the 4th index. So greater element 7. So that's why I written 4. Look for 1. What is the greater element? What is the first greater element? 7. What's the index? 4. And same for 8, 8. Because there is no greater element for them. For 8, there is no greater element on the right. Same for 4, no greater element. That's why I'm just writing the last, like whole array length value. Okay, which is 8, 8. Understood, Hariharan? We have to look for next greater element, and if there is no greater element, you just need to write the whole array length at that position, whatever the array length is. Understood, guys? So Joseph, for nested loop, you can see from here, if we just simply wants to do the same thing with for loop, we have to start from here. We need to check each element that 2 is lesser than any element. So this is like nested loops, right? So you can see at the first position I is equal to 1, then we will be running for all the jth loop, right? Same goes for 3 also. When we would be this position, we will be looking in this whole part. Same goes for 5 also. We would be looking in the right part. Correct, guys? Array length is 7. 3, 4, 5, 6, 7. Array length is 8, right? Oh, array length is 7. Sorry. Oh, yeah, yeah, yeah. Oh, sorry, guys. Sorry. Sorry. Yes. Got it. You guys are right. This should not be 8. This should be 7 because array length is 7. Totally agree. Thank you for correcting. Who was that? Arad. Yes, Arad. That's right. Correct. Okay. Last index is 6. Yes, last index is 6 and array length is 7. Totally right. So everyone understood how we got this array? Everyone understood how we got this array? First, because it still looked like a lot of people didn't understand how we got this array. And I'm sorry for when I made 8 for that, but that's why I want to repeat it again. If anyone has not understood, I can repeat it again. How we got this array 1, 2, 4, 4, 5, 7, 7. Everyone, it's clear? Okay. For doing this, I have also showed you this code. What would be the time complexity? Here. So the first loop it would be n, and in the worst scenario, we might find the greater element at the last. For 2, there could be scenarios we find the greater element at the last. So it would be like n minus 1, which would be n square. Right, guys? N square time complexity would be n square there. So now we will see how stack is going to help us to bring this time complexity to n. But yes, once we will include the stack, it is definitely going to going to increase our space complexity. Right now, we can see there is no space complexity. Simply we will just calculate the values and we can update our existing array. Right? So in this case, time complexity is definitely n square. But space complexity is 1. But now we'll see how we are going to use a stack and how a stack is going to help us to bring this time complexity little lesser. Okay, so let's see that. Yeah, it would be close to that. Okay, so let's see, guys. Let's write it again. And it's very important concept, guys. Same pattern, whatever we are going to do, the same pattern going to follow in the all 4 problems. Same pattern we're going to follow in all 4 patterns, all 4 problems. Okay, so let's write the same array again. 2, 3, 5, 1, 7, 8, 4. 2, 3, 5, 1, 7, 8, and 4. Okay, and let's take one stack here. And you guys know that this is our array only. You guys already know that this is our array, another array which we have taken. Okay. And now, guys, let's start from right side. Okay. So first thing, remember in the pattern, whenever somebody is going to ask you, find greater or lowest element at right, you always has to start your loop from right side. Everyone, please remember this. Pattern. I'm starting now. I'm telling you the pattern also. Whenever somebody is saying to you to find greater or smallest element at the right side, always you have to start your loop from the right side. Okay, so let's start understanding on the right side. Okay, so you tell me what's the greater element for 4 and the right side. What's the greater element for 4? And let's write our answer array also at one place. What is the greater element for 4? You guys tell me. Repeat this point, sir. So see, Joseph, I'm just telling you one thing to remember. Whenever somebody is saying, whenever somebody is saying to you that you have to find the greater element from the right or a smaller element on right, whenever they are saying next greater element or nearest greater element at the right side, whenever they are directing to the right side, you always has to start loop from the right side. Okay, so let's see for this. For 4, because there is no greater element, so we will keep an answer array, we'll keep the 7 here. Okay, in answer array we'll keep the 7, and we will insert this element into our stack. Two steps what first we did, we inserted 7, whatever the next greater element, next greater element index. Always remember guys, next greater element index we are pushing. Okay, so because there was no greater element, so that's why we are taking the length, so we have taken the 7 here. Now we will, and after that what we did, we have pushed that element into stack. So now 4 is in the stack. Okay guys, 4 is in the stack. Now let's move further. Now let's move here. Let's erase this one. Now we are at this point for 8. Now you tell me what is the greater element at the right for 8. You guys tell me what is the greater element for 8 at right. What is the greater element at right side? It's again 7, right? It's again going to be 7, and we will push our element 8. So Suraj, this was the last line only. Whenever we are finding, whenever there is no greater element, we are keeping the array length, and then we are pushing our element into stack. So now you can see 4 and 8 has been pushed. Okay, now let's look. Now let's move further. Now let's come back at 7. So now you guys tell me what is the let's write the indexes also. 0, 1, 2, 3, 4, 5, 6. What is the greater element for 7 at the right side? What's the greater element for 7 at the right side? It's 5. It's 5, right? So what we will do guys, how we are comparing this, we will be checking all the elements from our stack peak. We will be checking every time our stack peak and then compare these things. See how we are doing this comparing. We are always checking the peak elements. We are always checking the peak elements, right? So earlier what we did, let's move, let's move back a little bit. Let's move back. Let's try and let's understand that stack also, how the stack is performing. Let's move back a little bit. Let's move back guys. Okay, so now you know how the comparison will happen. We have created one stack, we have this array, we have started our loop from this side. So this is first element. So what we'll do, first we'll check, is there any element in the stack? Is there any element in the stack? No, right? Stack is empty right now. Stack is empty. So what we'll do, we'll first insert this element into stack. This is first step. We'll insert this element into stack, and then we will also update our answer array. Which would be 7. So for the first element, always the answer would be 7 for the first element, because there is no element at the next side, at the right side. That's why for the first element it would be always 7. But now let's look for 8. So what we will do guys, again same thing we'll be checking. Is our stack is empty? No, our stack is not empty. Now, second condition, what we will check. Guys, first condition, is our stack empty? This is first condition. Second condition. Now I'm talking about second condition. Is stack top is equal, or because we are looking for greater element, or greater, or greater, or for greater, just remove the equal part right now. Just take the greater one. Is stack top is greater than the element? This is the second condition. And what is the third condition? Is stack top is lesser than or equal? Here we can write the equal, or equal to the element. These are the three conditions, guys, which you need to remember for all three scenarios, because these only three scenarios could happen. So first time our stack was empty, we have simply pushed the element. So push the element. Now second condition, is the element is greater than stack? Is the element, or is the stack top is greater than element? Let's see. Stack top, which is 4, is greater than element? No. You can see, that's what the condition is. Stack top is greater than element? No, that's not true. Our element 8, it's not greater than stack. So what we will do, we'll simply again push it. Push the element. In both scenarios, we are pushing it. And again, here 7 will be coming here. And now we'll push this 8 here. Correct, guys? Now we have pushed it. Now let's look for this. Now let's look for 7. Now see, is our stack empty? No. Now let's look for second. Is stack top is greater than element? Is stack top is greater than element? Is stack top is greater than element? Yes, it is. Yes, it is. Right? So just return the index of that element. Just return the index of that element, which would be 5. Which would be 5. Right, guys? Because it is the greater than that. So that's why we got the 5 here. Now let's look for 5. And now we'll push our 7 also here. Now we'll push the 7 also here. Correct, guys? Now we'll push the 7 here also. Now let's look for this. Now let's am I missing any step? Just 1 minute, guys. Now for 1, it would be 7. That's correct. It would be 4. Correct. That's the next greater element. Now let's look for 5. Yeah, and we will push the 1 here. Correct. Right. Right. Ah, okay. I missed one thing here. Okay. Okay. Correct. 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 Ah, okay. Okay. So I think I missed this part. The third condition. Okay. Now it will come. See. Now it will come, guys. Now it will come. So now let's look for 5. When 5 is coming, you can see our element is lesser than the top, right? Our element is greater than the stack top. So what we need to do in this situation, actually, we need to pop it. We need to pop this element, and we have to pop till then our stack is empty, or our stack is or any of the top element is greater than this element. Actually, 1 minute. Yeah. So guys, see, these are the three conditions, guys. Only these are the three conditions. In these three conditions, only we have to work. Okay. So first condition, is our stack empty? If your stack is empty, push the element. Okay. Let me again walk through again. I think I missed one situation, one scenario earlier, which was not the correct. Yeah. So 1 minute. Let me just draw it again. So first condition, guys, is our stack empty? Push the element. So 4 was there, 4 got pushed. I think I missed it here only. Next element, whenever is coming, next element 8 is coming, we need to compare it. Is our stack top is greater than this or not? It's not, because the stack top is smaller, right? So we need to pop here again. We have to pop it here only. This 4, we will pop it. We do not want, because we know that all the elements which are coming next, all the elements which are coming next, these all 4 will never be greater for anyone, because we already got 8, right? Because we already got 8, that's why we do not need to keep 4. Understood, guys? Because we already got some greater element than 4, then it means for remaining element 4 never going to be greater, right, guys? Understood this thing? What I told? I missed that scenario actually. Whenever whenever we are getting any element and that element is greater than the element which we already has in the stack, so it means what it is referring to? It is referring to that the smaller element who is in the stack is not going to be greater for any other element. We are only going to keep here all the greater elements. In the stack, we are only going to keep the greater element. So that's why this is the third condition which I was talking about. If stack top is lesser than or equal to the element, because you can see right now stack top is lesser than the element. So what we need to do? Here two scenarios. Here two scenarios. We need to pop it, and we need to pop it till our stack is empty, or any of stack top is greater than the element. See, it's just with the visualization. You will just get this with visualization. You can see now 4 is smaller, so we do not need 4. So that's why we'll simply pop it. So once we will pop it, we will not get anything as stack. So now our stack is empty. So now once our stack is empty, we'll again push the 8 here. Now again, let's see 7, which is not greater. We'll simply push the 7 here. Okay. And for 7, we'll keep the index here, which is 4. Now let's talk about 1. 1 is also smaller. We'll simply push it 1 here. And for 1, the next greater element is 4. We'll keep the 4 here. Now let's talk about 5. 5 is the initial. For 5, 1 is not going to be greater, because 5 is greater. That's why we will pop this one. And we will pop this one. We will pop our stack till we got the next greater element, which was 7, and our 7 is greater than 5. So we will keep this index. So what is the index for 7? It will be 4. Again 4 will be coming here. For 5 also. Correct? Now let's talk about 3. Now let's talk about 3. Right? I think for 3, the next greater and the top element is 7. So again, the index is 4. Correct? Now let's talk about 2. For 2, the next and push and 5 and 3. Oh, actually, I'm getting 1 minute. Actually, I have not pushed the element. After 5, 3 will be here. See, after 5, 3 will be here, right? So for this, 2 will be the index. Sorry, guys. For after, because I have not pushed the 5 and 3, I was just comparing it with 7. So that's why I was writing 4 every time. So for 3, it's 2. Yeah, index is 2. Now look for 2. So for 2, 3 would be the greater element. So we're writing out the 1. And at the end, we just need to reverse it. So 1, 2, 4, 4, 5, 7, 7. I hope this is similar to the earlier one. 1, 2, 4, 4, 5, 7, 7. You see, this is the similar thing. And I will just repeat this thing again, no problem. I know this was little confusing, but you guys need to understand very importantly this scenario. Otherwise, we will always, because this is going to be used many places. 0, 2, 1. This time I'm taking some different example. 7, 8, 4. Because See, I have also not remember everything. I have also not remember anything. I'm also just doing it, and just because I also remember the logic in these three conditions only, which I written it here. Okay, so I'm just trying to make my logic like just trying to tell you guys also like that. Okay, so let's start again, guys. No problem. Let's start from stack. This is our stack. Okay, let's start from right side for 4 because our stack is empty. So we will first push 4 here. Okay, and in answer array we'll keep the array length. What is the array length? 0, 1, 2, 3, 4, 5, 6, 7. Yeah, array length. Correct. That's what we'll do. Now let's look for 8. Now let's look for 8. This is our third condition because you can see R8 is greater than this. R8 is greater than this. So it means we have to pop it. Whenever we are getting any greater element here, we need to remove it. So we will pop this 4 here. Now 8 will be inserted here and same index 7 because there was no element. We only have to take the top element index from here. There was no element, it means 7 will be there. Now let's look for 7. Now let's look for this element 7. What we need to look, is this 7 smaller than this or greater than this? We just need to look 2 scenarios for each element. Is this element smaller than the top or is this element greater than the top? Only two scenarios. Is this element which we got in this iteration, is it smaller than the top or greater than the top? If it is greater than the top, simply push it. Simply push it and take the index. So what is the index of 8? 0, 1, 2, 3, 4, 5, 6. Because 8 is greater than 7, so we'll take the 5 index here. And we'll simply push the 7. Okay, we'll simply push the 7 here. Let's look for 5. Let's look for 5. So for 5, let's compare it. 5 is again smaller than this. 5 is again smaller than this. If it is smaller, simply push it or take the index. So index would be 4 here. And push the element here, 5. जब तक छोटा आता जा रहा है, we will simply push it. Okay, 5 is there. Okay, yeah. Now let's look for 1. 1 is smaller than this. Yes. So simply take the index of the top, which is 3, and take the 1 here. Now let's look for 2. Now guys, now let's see. It's not smaller. 2 is not smaller. Now we need to do popping. So we will simply pop this element. And we will be doing this popping until, guys, we will be doing this popping until we got the greater element. And you can see for 2, 5 is greater. So we will stop here. For 2, 5 was greater. So we will stop here. And we will simply pop it. And we will see, take the 2 here. 1 minute. What was that? It was 5. Sorry, 3. 3. Index 3 would be here. Index 3 for 2. And we will push the 2 here. Now let's look for 0. Yeah, 2 is greater. So we'll take the 1. And then at the end, simply reverse it. 1, 3, 3, 4, 5, 7, 7. This is the indexes. We'll get the indexes. I hope with this second example, you guys understood little bit more than the first example. Did you guys little bit more understood compared to the first one? And guys, same logic is going to apply in all 4 questions. All 4 questions. We just need to change our conditions everywhere. Same logic is going to be do everywhere. No, it's not also n square. It's not n square. For taking the top element, so it's see we can say, see, the another loop we are doing it only some scenarios. In this scenario, right, stack top, in this scenario we are just simply doing the popping there, correct? And in the popping we believe that is going to be because in the stack it's always going to be last element deleted. Yes, sorting takes time too, but in the stack, the popping operations, they simply take it as a O1 mostly. in the stack, see, because it's a contiguous memory and we are deleting it from the last. So let's see in the JavaScript how much time complexity they say for pop. Okay, let's see. But I believe it's going to be 1, but let's see. Okay, because you see, so the first thing we how many loop we are running. This is the first loop which we are running, and correct. Second thing, for finding out the top element, it's we already know the index, so we can simply do that. Simply we can do that length minus 1. This one will get the last element. Now talking about the pop element, pop operations, I believe it takes the 1, but let's see. Let's look into the here pop operation in stack. Or we can simply look for time complexity for that, right? Or push and pop in stack. For all the standard stack operation, push, pop, and is empty, the worst case runtime complexity can be O1. Okay, so they implemented in this way. The pop operation is always going to take the O1 standard. It's always take the O1. So 1118. This is worst case. Then we have to pop all n minus 2 elements. Yes, yes. In that one case, yes, I was thinking about that only. That in the worst scenarios, because we need to iterate all the elements from the stack. So that could be near to like more than n. I would say that because let's think about it. Because see in this example also 118. So 8 would be the first element, right? Inserted, and after that there will not be. This is not the worst case which you have showed like it. This is the best case actually, because in this case there will not be any while loop will happen. There will not be any while loop will happen. Why there was only once in stack if it was already in there? Why there were only one in stack if it's already in there? No, he was telling that actually this is the element in the array, not in the stack, Vishal. Okay. So this is the best case, but yeah, actually yes, I agree with that. That it will not be n in all scenarios. It will not be n in all scenarios because we have to do. We will not push all ones in stack. In the duplicate scenario, if we have the 1 and 1, we can stop it there, right? We can stop that. In the duplicated scenario, let's see, let's take example. Why not? Let's try to understand with example, no problem. Let's see, if we have similar array like 1 1 1 and 1, then we have 8. So how we will start? We'll start with 8, right guys? And then we'll see 1 here, right? And then we'll see, then is it the greater than? Yes, it is greater than, right? So we'll simply push it. We'll simply push the 1. And again we'll see the 1. We'll simply pop it. We'll simply pop this 1. And then again 1 here. So this will happen, Likit, in this scenario. Always we 1 and 8 will be there. Not like that 1 1 1 1 1. We are just simply popping it out and then we are doing it. But yes, see, in some scenario, is there any scenario? Yeah, like in this scenario, you see, in this scenario, 10, 2, 5, 7, 8. If this is example, if we got the largest at the starting, then we have to pop every element. Then we have to pop every element. Like in the first, it would be 8, then would be 7, right? Then would be 5, then would be 2. Now we got 10, right? Which is greater than a top element. We have to pop this one, we have to pop this one, we have to pop this one, we have to pop this one. And then we will get the 10 here. So in that scenario, I'm thinking the time complexity will not be n in that scenario, right? Because we are doing the 4-time while loop. Right? For the last element, for the last index, we have done the 4-time popping. So that's why these are very worst scenarios, but yeah, like if we got something like this 10 9 8 7 6, 10 9 8 7 6, this could also be the worst scenario for this. So let's see, first we'll insert 6, right? I think we'll do the popping here, then we'll insert the 7, do the popping. This is not the worst scenario, by the way. This is not the worst scenario, just simply doing one popping, which is the constant time. But yeah, this could be the worst scenario, right? Yeah, worst scenario, it could be a n square. That's totally right. In worst scenario, it could be n square. I believe that. Okay, guys. Let's see what this is. What they say. Is there anything in the time complexity they are talking about? Let's see. So they are telling time complexity is n square, and for the earlier method. They are saying it is an n, but I'm not sure about that. But let's see. But I will check about this because I believe it should not be n, right? It should be more than n. But yeah, it's better than in some scenarios. It's better than the previous one, I believe. Yeah, we can go for a break and then we can come back. Yeah, better than definitely the better than the for loop. Agree. Okay, so we can go for break now, guys, and then we will quickly see the code of it. Okay, we'll quickly see the code of it, and then we will also see all the remaining 3 scenarios, because all those 4 scenarios are going to be used many places. Okay, guys, so now it's 9:55, so we all can come back at 5, 5, and 10. Yeah, so we can all come back at 10, 5. 10, 10, okay, 10, 10, yeah. So Deepak, question was, so if we have this array 10, 2, 5, 7, 8, for each element, we want to find first greatest element. For each element, we want to find first greater element. So for 10, there is no first greater element. All are smaller. So we will simply put array length there. Whatever the array length is there. So array length would be like in this scenario, 1, 2, 3, 4, 5. Array length would be 5. Correct? Okay. For 2, what is the next greater element? Which was 5. Which is 5. So we'll simply return the index for that index. It would be 2. Look for 5. It's 7 only. 3. First greater element. For 3, it's 4. For 7, it's 4. For 8, there is no next greater element. We'll again keep the array length. So that's what the question actually, Deepak. Okay. Okay, so we'll come back at 10:10. Okay, guys. Let's meet at 10:10. Is everyone back? So Likhit is back. What about others? You guys are able to see my screen? Sorry for that, guys. Okay, so let's start. Okay, 1 more minute is there. Before that, do you guys have any questions? Did you guys understood the pattern? So pattern is very easy, right? So if somebody is asking the greatest element at the right side, so first thing, we have to start from right side. We have to start our loop from right side. Okay. Now, when we are starting from the right side, if our stack is empty, simply push that element into stack. Simply push that element into stack. Okay. Now, second scenario. When our stack is not empty. When our stack is not empty. Okay. So now our stack is not empty. So we need to check. We need to check whatever element is coming from stack and our stack, whatever element is coming from array or from our problem, that element is greater than the stack element. If that element is greater than a stack element, we need to pop it out. Whatever exists in the stack, we need to pop it out, and we have to pop. We have to do popping until we got any greater element with the element which we got. It's just the visualization. Again, guys, it's all comes to visualization. Okay, I will also start writing the code, and that code will again into the visualization. I have not remember anything, any line or anything like that. It's just on the visualization, and I will visualize it. And the same visualization I want to give it to you guys also. Can you guys visualize it now? How the code is working? Because if yes, then you guys are going to run it now. You can easily now write the code. Everyone can visualize it because visualization is very important here. Once you will visualize how many lines you have to write, everything is very easy. The visualization is very important here. Okay. So let's see. There is one question in lead code. It's little bit different, but similar to that only. So I will try to do it in. Yes, Parag. It's the same question. So in the slide, rather than printing indexes, we are printing elements there. So in the slide, in the same question, Parag, if our question was 10, 2, 5, 7, 8, in the same question, what they did, we are taking array dot length, right? They are taking it as a -1. They are taking it as a -1. So for 10, next greater element, there is no greater element. So print -1. For 2, 5 is the greater element, print 5. For 5, 7 is the next greater element, print 7. For 7, 8 is the next greater element, print 8. For 8, there is no greater element, print -1. That's what they are doing in the slides. So these things, guys, -1, array dot length, these all things will be decided based on the problems. Sometimes you need to take the indexes, sometimes you need to take the values. So these are not very, like, these are not the things which are very different. You can make according to it. The main part was logic. Okay, Parag? So it's for everyone. In slide, when you guys will see, you might get confused that it is coming different results. So in slide, they are returning the elements. They're not returning the indexes. We can also return the elements also. We can return the indexes also. It's not difficult, right? At one place we are returning I, in another place we are returning array of I. Simple as that. Somewhere we are taking array of dot length as a outer bound. Somewhere we are taking -1. Somewhere we are taking 0 also. 0 I think we are not taking anywhere. Yeah, we'll see. We'll see. Okay. So let's start from our coding part. Okay. So let's understand this question also, but we will not solve this question. Okay. In this question, what they are saying similar question. They're saying similar thing. So they have given one array num2 1 3 4 2, and they are saying you need to find the next greater element for this nums 1. Okay, let me give you. Okay, so because we are doing the questions, let me give you the visualization. They have given us two array, nums 1, which has 4 1 2, and then they have given us num 2, which is the original array, 1 3 4 2, right? 1 3 4 2, and they are saying this nums 1 is the sub array of this num, or like part of this array, not sub array, part of this array. Okay, so now they are saying you need to find the greater element for 4, greater element for 1, and greater element for 2 in this array. In this array. So how we will solve this? First we will calculate the next greater element for this array. So you tell me the index. You have to tell me the index. For 1, what is the next greater element? You have to tell me the index only. What is the next greater element for 1? Let me come back to chat. It's 1, right? Index is 1, correct? What about 3? What's the next greater element index for 3? 2, right? What about 4? There is nothing. You can take the length, or actually in this question they have taken -1. You can take length or you can take -1 also. See, in this question they have taken -1. They have taken the -1. So we will take the -1. Okay. So for 4, there is no greater element. We are taking -1. For 2, there is no greater element. It's -1. So now let's look for this. For 4, what is the next greater element? -1. For 1, what is the next greater element? It's 1. And for 2, what's the next greater element? -1. So this should be our answer. Let's see. So our answer is -1, 3, -1. So again, guys, they are not taking indexes. They are taking the element. They are taking the element. So you know that you can correct this thing, right? You can take the element also. So what is the greatest element of our 1? What's the greatest element for 1? It's 3. What is the greatest element for 3? It's 4. What's the greatest element for 4? There is nothing. Take -1. For 2, -1. That's what the answer is. See, guys, why I am telling you the indexes, there will be a lot of problems I have seen where they are using only indexes, not elements. Okay, explain number 1. Explains number 1 output. Explain number 1 output. Yeah. So Suraj, this time we are not taking indexes. These are elements. So what is the next greatest element for 1? It's 3. So I've taken 3. What is the next greatest element for 4? For 3, it's 4. Taken 4. There is no greater element for 4, 2. So I've taken -1, -1. Understood? First one, 4, 1, 2. So 4. So we are just simply taking answer from here. For 4, check answer here. It's -1. So I have taken -1. For 1, answer 3. So I've taken 3. For 2, answer is -1. Taken -1. Understood? For index, we have to go through the array. We still go through the array only, Vishal. It's not difficult. Like index, or when you are returning indexes, you can return the. See, Vishal. So somewhere, if you are returning I, how you return index? You return with I, right? You run one loop. I equal to 0 to I less than array dot length. If you are returning I, instead of that, you return array of I. Understood, Vishal? Got it? Okay. So now let's jumping into the code, and we are going to do with, and see, we are first going to calculate the next greater element array for nums 2. So let's take first answer array, or we can write it next greater element. Next greater element in a small, next greater element. Right now it's empty. Okay. Guys, let's start from first loop. It is going to be start from last. So nums 2 -1. Let I is equal to nums 2 -1. I greater than equal to 0, I plus plus. Sorry, I minus minus. So now, so if our array length is 4, so our array length is 4, so it will start from 3. So 3, 2, 1, 0. So all 4 element we will traverse. Understood, guys? These 2 lines, everyone understood, right? So see, I didn't remember anything. I'm just doing it in front of you. So 3, 2, 1, 0. 4 times this loop will run. Okay. So now, what is the first condition which we did? And let's take one stack also. Let's take one stack, which is our array. Okay. This is for our answer. This is a stack which we'll use for traversing. Understood, guys? Okay. So now let's check for if stack is empty. How can we check it in array? We'll do stack dot length is equal to 0. If our stack dot length is 0, it means stack is empty. If stack is empty, simply in our nge dot push -1. हम देखो विजुलाइज भी करते हैं यहाँ पे. We'll also visualize whatever we are writing. We'll also visualize it here. Okay, let's take the same array. What was the array? 1 3 4 2 1 3 4 2. हमने दो एक आंसर बना लिया है. आंसर नहीं, nge, sorry. We have created one nge and we have created one stack here, right? Now first condition we checked, and now we are starting from this place, 0 1 2 3. So our third loop is running right now, right guys? Our third loop is running right now. So now you can see in this loop our stack is empty. This is our stack which is length is empty. So what we did, we are doing nge dot push -1. It means in this nge we are pushing first -1, because you can see there is no greater element after 2. So always first element would be -1. Okay, -1 or array length, anything you can take. So I'm for this scenario I'm taking -1. Okay, so -1 is there. And what is the next thing which we need to do? What is the next thing we need to do? We need to push our element in stack. So stack dot push array of I. We are not putting index. We are pushing the element directly. Array dot I. So right now in our array now 2 has been inserted. Understood? This much code everyone understood? First iteration everyone understood? nge I. Nums dot length -1, nums 2 dot length -1. Did you guys still have question for that? Oh, array is not defined. I have taken array somewhere. 1 minute. Oh, sorry. Understood. Okay. You guys were taking nums2. Okay. It will be nums2. Okay. Got it? You wrote it wrong. You wrote it wrong. The I also wrote. I wrote it wrong. Where I is there. I is there. I is there. But where I have written wrong? I is equal to nums2 dot length -1. Oh, okay. Nums2 dot length. I see. Okay. Yeah. So I is equal to nums2 dot length -1. Correct. Understood. Yeah. Okay. So let's move further, guys. Now, what is the next condition? Now we have first element in our stack. Now our iteration will go for 4. Now our iteration will go for this. So what we need to do? We need to compare this element with our stack top element. If it is greater, if this element is greater, so we need to pop it out, this new element. And if it is not greater, like just understand the scenario. If we have 5 here, and if we are getting any element which is lesser than that, so we'll simply push it here. So we will first create this scenario. So we'll first create the direct push scenario. So if stack or stack dot length -1, which is the last element, if stack dot length -1, it will give us peak element is if this element is is greater than, if this element is greater than the element, then we have to simply push it. So it is, if it is a greater than that, if it is greater than nums2 I, so we just simply need to push our nge dot push, nge dot push, and this element, same element we need to push from the our stack. Correct, guys? That's what we need to do. If we got, if just consider if we have 5 pair, right? And if like if just take this example 1 3 5 4, right, guys? Or 5 8, sorry, 1 3 5 8. If this is the example, so what we will be doing here? First 8 will be pushed here. Then we are checking if stack element is greater than the element. So then simply push this one and put 8 here. Put 8 here. So that's what I'm doing. nge dot push stack dot stack dot. Now we will look for the next element, next condition. Now we will be looking for the next condition. Else if, now we will be looking for the next condition, guys. And that next condition would be if our stack dot length element is smaller than that. If it is smaller or equal, both scenario. We'll take both scenario. Okay, we can take both scenario. If stack or stack, if now the earlier case, now it will be coming back to earlier case where we were having 1 3 4 2, 1 3 4 2. Now this is the scenario. Now 2 has been inserted. Now 4 is there. Now 4 is trying to insert. So now it has checked this element is smaller. So now what we will do? Now nums2 is greater. Now nums2 is greater. So now what we need to do? We need to put one while loop here. And inside this while loop, we need to do the stack dot pop. We need to delete. We need to delete the 2 from here. And what and where we will stop this while loop? We will stop this while loop in 2 conditions. If our stack dot length is greater than or equal to 0, then continuously run this and continuously pop it. If our stack dot length, because in this scenario 2 will be deleted, then our stack dot length would be 0. So we will be stopping it here. If our stack dot length is I think is greater than 0 only. Stack dot length, if it is greater than 0, it means there is one element. If it is equal to 0, it means there is no element. So if it is simple, we can say stack dot length, it should be greater than 0 and is stack peak element, stack dot length, stack peak element should be stack element. So let's see, 2 4. Now sorry, 4 has been removed. Now 4 has been removed, right? Now 3 will come. So 3 will be coming here because it's smaller. 1 will be no, do not take this scenario. Take any other scenario like 2. Take this scenario 10 2 5 8. In this case, we will easily understand. So 8 will be coming here, 5 will be coming here, and 2 will be coming here. Now we need to insert the 10, which is greater than the top element. So we need to delete it. And meanwhile, let's insert 11 also. So we will understand where we have to stop, right? So first 11 will be inserted, and all the smaller element will be on the top. So now 10 we have to insert. So first we need to pop this one, then we need to pop this one, and then we need to pop this one. So we need to stop at this place because 11 is greater. So we need to continue our popping till we got the greater element. So that's what we need to do. We need to continue this popping till our stack elements are lesser than nums2i or equal, lesser than or equal. Then we need to do the pop part. Understood, everyone? I showed you with this example. We need to do the popping till our stack elements are lesser than the current element. So that's what the 2 conditions are here. In these 2 conditions, continuously popping will happen. In these 2 conditions, continuously popping will happen. And now once the popping is done, we need to check 2 things. Again, if stack dot length, same thing, this thing. If stack dot length is 0, we need to insert ng dot push -1, ng dot push -1, and this condition we can again check, because this is the second scenario, right? This is the second scenario. This is the second scenario, guys. The stack dot length should be greater than num2, because तभी हम रुके ना, जब ये एलिमेंट ग्रेटर हुआ तभी हम रुके हैं, तो उस केस में stack dot length match. That's what, guys. This is the whole code for greater element. Now let me print NGE for you guys. At the end, let's print the NGE, console.log NGE, and let me return something from here. Otherwise, this code will not run. So return nums1. Just simply return nums1. Let's see if we are written anything syntax error or anything like that. Okay, somewhere syntax error is there. So num2. Okay, so it should be nums2. And what else? What else? Let's see. Yeah. So why is there a num1 is not defined? Okay, nums1. Wrong answer should come, right? Not a syntax error. Yeah. So we can see standard output is coming as -1 4, 3. Let's see. Is it coming for us also? Yeah. You can see we have not reversed it, guys. We have not reversed it. I told you, right? After that, we have to reverse it. After that, we need to reverse our NGE. So if we do the reverse simply, NGE dot reverse, that's a method, right? Array has reverse method in array in JS. I think it's array dot reverse only. Yeah, array dot reverse. So if we simply do reverse there, so we'll get the correct output. Let's see. You can see 3, 4, -1, and that's what our output was. 3, 4, -1, -1. Correct, guys? That's what our output was. So let's understand one more time. Okay, before that, let's see your queries. Array is not defined. You wrote it wrong. Okay, else is enough. Pop 21 line. Explain, please. 21 line and 24. Okay. 21 and 24. 21 and 24. Yeah. So Suraj, these are the scenarios. These are the scenarios. So when same this example. So we have inserted everything, right? So now we started from here. We inserted 11. We checked 8 is smaller. Yes, inserted. 5 is smaller. Inserted. 2 is smaller than 5. Yes, inserted. Now 10. 10 is smaller than 2. No. In this case, 10 is not smaller than that, because this is keeping all the greater element. So 10's greater element is 10's next greater element is not 2. 10th next greater element is not 2. So we started popping. So we started popping it out. So we will start popping till we got the greater element. So that's what in the 24 line number, after our while loop ended, I'm just simply checking it. We do not actually, this line is definitely not needed. We can simply remove this condition and we can simply push it. But I'm just for safe check, I'm again checking the last element in the stack should be greater than nums2. So that's why last element in the stack should be greater than nums2 or this element. Then only I will insert it. Then I will insert this last element. And this is the scenario when there is no element. Like if I remove the 11 also, if I remove 11 from here, so 11 will not be here also, right? The loop will start from 8. So this 11 will also not be there, right? So last condition is this one. So now everything will be popped. Our stack length will be 0. So that's what in those scenario I need to push ng.push -1. For this element there is no greater element. So push -1. That's what the line this line is doing. Understood? 21 and 24 line. These are just the safe check. These are just the safe check. After popping, we are not pushing into stack. So no, we are pushing every time into stack. You see the last line. If you stop, if you close all the if and else, you see this is the every time we are pushing at the end. If you close all the if and else, you will see at the end We are pushing it. Let's just correct it a little bit. It will look good. Yeah, you can see at the end, Joseph, we are pushing the stack. Okay, every element we are pushing in the stack. Understood, Joseph? Okay. Explain entire code again. Sure, Deepak. We'll do that. Anyone else has having any specific question, or let's start explaining this code again? Anyone has any doubt? Okay, let's try to. Okay, let's try to explain it again. Okay, our answer is coming. We are manipulating in ng and returning number. Oh no, returning in number नहीं. ये सिर्फ हमने किया है अपने टेस्ट केस को रन कराने के लिए. अभी आंसर नहीं आया है. We have not seen the answer. We are just simply returning the nums one. I just showed you the next greater element for each element in this array. This is not the answer. Understood, Sarad? Who was asking Sarad? This was not the answer. I just showed you next greater element for that array. Okay? That was not the answer. Okay, so let's start understanding our question. And our question was this, guys. 1, 3, 4, 1, 4, 2. And we want the next greater element for each element in this array. Okay, and if we do not have any next greater element, we have to put -1 on that place. Okay, guys, we need to find each greater element for each element here, and then if we do not have anything, then we have to put -1. So let's start from 1. So for 1, the next greater element was 3, so we put it 3 here. For 3, next greater element, first next take na hai, first next. So now first next greater element is 4, so we have to put it 4. For 4, there is no first greater element, so we need to put -1. Same for 2. That was our output which we were looking for. Okay, so what we did, guys, we started from back side. Okay, and we have taken one stack. So that's what you can see. We have taken one stack and we have taken one array for to keeping all of our answers. Okay, and then you can see we started our loop. Let me expand everything. Yeah, now let's give some space so everything could be look better, right? Let's 1 minute. Let me expand everything, and yeah. Okay, so it is still not properly indexed, but still, let's see. So yeah, so we started our loop from the last element. You can see for nums 2 dot length -1, we started our loop. First, we are checking is our stack is empty. Yes, our stack is empty. It's the first iteration. So if our stack is empty, just simply in answer put -1. And logically, for the last element, always next greater element would be -1. Logically, for the last element, there will not be any greater element. So that's why automatically it will be -1. So that's why answer is -1 in this scenario. This line actually you can keep it out also, out of while loop, and you can start from ng nums2 length -2 also, because this is by default line. Every time this line will be only one time this line will run, and only one time this line will run only in starting. Okay, let's move further. Then we are checking and then you can see this loop will not run, this if condition will not run, because it is checking for the top element, because our stack is empty right now, so there will not be any top element. This all condition will fail for the first iteration. I'm telling this all condition will fail and it will push that element, stack dot push nums2 I. So now in this stack we have pushed the 2. Okay, now next iteration which is running for 2. Earlier I was 3, now I is 2. Now it will go for here stack dot length -1. Is it greater than nums2 I? तो जो हमारा पीक एलिमेंट है क्या वो ग्रेटर है नेक्स्ट एलिमेंट से? नहीं. You can see is 4 greater than 2? That's what I'm checking. Is 4, no, sorry, I'm checking for opposite one. 2 greater than 4. Is 2 greater than 4? You can see stack dot length. It means peak element. So peak element is 2. Is 2 greater than 4? It's not. It will go into the else if condition. It will go into the else if condition. And else if condition was same. Stack dot length, is it less than nums2i? Yes, it is. You can see 2 is less than 4. It is. Then what we did? We started one loop because we need to pop this element logically also. Now see this thing logically. If we got a next element, if we got any greater element than our element in the stack, it means this 2 is not going to be greater for any of earlier element, any of the remaining element. अगर हमने इससे बड़ा कोई मिल गया हमको, if we got anything bigger than that, तो जो हमारा पहले का एलिमेंट है वो अब किसी के लिए ग्रेटर नहीं होने वाला. That is logically. So that's why we have to pop everything, whatever is down to that. So that's why we started popping out here. In this while loop, you can see we are simply doing popping out. And when we are stopping this popping, only in two scenarios. When our stack length is becoming 0, in the similar scenario, first time we'll do the pop, our stack will become 0. So we will stop it there. This is the first time. And second time, we will be stopping it if there are many elements in the stack, like 5 or 6, and we got somehow, like we have, 1 minute. So we have something like 8, 7, and 4, and somehow we got 5. So we need to stop popping when we got greater element than that, greater element to it, which is 7. So we have to only pop 4 at that situation. So that's why we're stopping it in 2 scenarios. And then after that, once our stack is empty, we have already popped it out. So we are checking right now what is the current condition of stack. Is it stack empty, or if it's not, then is it I think then we are checking, is the stack length minus 1 is greater than nums2i or not. Both scenarios, whatever the scenario is, if it is 0, I am pushing minus 1. If it's not, so push the top element, which is 7. So that's what happening in the code. Okay, everyone understood? Was it difficult? You guys tell me. Whatever we have visualized, we have written similar way. One comparing two arrays, nums1 and nums2. Are comparing two arrays, nums1 and nums2. Yeah, we have not used nums1 Joseph till now. We are using stack array and nums2. Correct? We are using our stack and nums2. You guys tell me, was it difficult? We have not solved the question, Joseph. See, we have not solved the question till now. We have taken this question, just trying to find out what we learned. We learned that how to find the next greater element for any of the array. Understood? So that's why, sir, line 23, why again pushing minus 1? Why again pushing minus 1? Which is line 9? Yeah. So this one is for this scenario, right? You see, after first we pushed 2, when we got 4, so we want to find out the next greater element for 4. There is no element for 4. So we have to pop it out. Everything from here. Once we pop it out 2, it was empty. When we got stack empty, you always need to push minus 1. That's why you can see 2 minus 1 in the answer. Understood? Who was asking? Hariharan? Okay. Now guys, let's talk about the smaller one. If we want to find next greater element to the smaller, can you guys tell me what are the changes we need to do in the code? It's the same code. If we want to find out next smaller one for the same array 1, 3, 4, 2, if we want to find out the next smaller element, so let's find it out first. So for 1, next smaller element, is there any next smaller element for 1? No, right? It would be -1. Is there any next element? Is there next smaller element for 3? Yes, 2 is there. So 2 would be there. Is there next smaller element for 4? Yes, 2 is there. Is there any next smaller element for 2? No, -1. Right, guys? That should be our output. That's right, guys? That should be our output. Everyone agrees? So now you guys tell me what are the changes we need to do in code to get the same result. To get the same result, guys, there is no changes you need to do wherever you are doing the greater. So right now you're checking for greater. Now you need to check for lesser. Once you got the lesser element, push it. Once you got the lesser element, push it. Now, once you got the greater element, you have to do the popping again. You have to do the popping again. You have to do the popping again. Right? Let's see. Are we getting the same result or not? We have changed everything. We just changed our arrows. Okay? We just change our arrows. Let's see the same result is giving or not. Let's see, guys. Or is there anything else we have to do? So we got -1, 2, -1, -1. We missed one thing for 4. For 4, we are missing 1, 2. For 4, we are missing 2. What happened for 2? So we started from back. Anywhere you guys are seeing any mistake which we did, which I did? Okay, sir, for 3 is equal to -1. 3 is equal to -1. Why? It would be 2, right? 2 is the next smaller. 2 is the next smaller. Same arrow you missed to change. Same arrow you missed to change. Which one? This one or this one? So see, let's see. So once we are looking for the smaller element, right? So in the stack, how will this happen? Let's see how will in the stack will happen. So first time 2 will be pushed. Now we need to push the. You can see in the greater we were decrementing, right? Here we will be incrementing. So let's see. 2 is there. So this is the next smaller, right? So for 4, yes, 2 is the next smaller. So we will push the 4. We will push the 4. And yeah, we will push the 4. Correct. And for 3, which is smaller, 3 is smaller. So we need to pop it out. We need to pop it out. And we need to pop it till we got the lesser element. So our stack element should be lesser. Should be lesser than the current element. Should be lesser than the current. Our stack element should be lesser. Oh, it should be like this actually. Right? It should be like this, right? Our stack element, we have to do the popping until we got the lesser element. So less than equal to this thing, right? And I think we have to do this also here. Correct? What about here? If stack dot length, yeah, this is correct, right? Yeah. If stack dot length is greater, yes. If stack इसका ये जो एलिमेंट है अगर इससे ग्रेटर आता है, जो हमारा करंट एलिमेंट है उससे ग्रेटर आता है, तो हमें अंदर जाना है और पॉपिंग करनी है. लेट्स सी दिस टाइम. Are we missing any scenario? Hey, something is missing. We are something missing. I think it's happening in the popping only. 2, -1. Let's see. Okay, so I think. So let's revert back. I think it should not be that much changes. It should be arrow changes only. But let's see. First, let's get back to our previous result. Okay, that was the previous one. Let's see. Let's see our result first. Yeah, so 3, 4, -1. Yeah, this was the first scenario. 3, 4, -1. Correct. Meanwhile, let me see if you guys Have any doubt in meanwhile? What happened, Vishal? Did you not understood the first scenario? The first one where we were looking for next greater one? Acha, that was about the answer. 1 minute, Likit. I will just look into the doubt. So let's see in this one if you want to see, because I'm sure we should not make that much changes. Let's try to understand. This one 1342, same problem. Okay, 1342. The first scenario is when our stack is empty. So we'll do the 2. We'll insert a 2. That is the first scenario. Stack length is 0. In our answer, we will be pushing -1. Right, guys? We will be pushing -1. Let's look for next one. We are looking for the smaller one. Always remember, we are looking for right now a smaller one. So now 4. What is the next smaller for 4? 2. Yes. So we got the smaller. So we will be printing out this one. We will be taking this one and printing out. So let's see this condition is there or not. So if stack dot length is greater than nums2, is greater than, so this is not, we have to take the smaller. So ये stack की length is smaller होनी चाहिए, right? So we will first change this arrow. So now our stack element is lesser than nums2i. Now our stack element is lesser than this. So we are simply pushing into 2 and this loop will be stopped, and then 4 will be pushed here. 4 will be pushed here. Right, guys? 4 will be pushed here. Now let's look for 3. Now let's look for 3. Again, stack element छोटा होना चाहिए, हमेशा यहाँ छोटा element होना चाहिए इससे. But 3, 4 is greater. 4 is greater. So it is going into the next condition. So now it is going into this one. Stack dot length is greater than or equal to nums2i. It is going into this condition, right? So we have changed the second arrow. Now let's move on. Now we need to do the popping out. So first condition is totally true. If stack dot length is greater than 0, that's totally true. Let's look for this condition. This condition is little bit confusing actually. So now we need to do the popping for 4. We need to do the popping for once we do the popping for 4. Once we do the popping for 4, so we will get the 2, right? So now where we have to stop? Where we have to stop here only. So once we got the top element is lesser than this one, is lesser than this one. So top element should be lesser than, yeah, lesser is also only there. Lesser than or equal to. Lesser than or equal to. Yeah, equal is also fine. Lesser than or equal to nums2i, then we need to pop it. No, I think we need to do the greater actually. जब तक हमारा हाँ यहाँ पे ना हमें greater करना चाहिए. See, हमें जब तक we have whenever we are getting the greater element, we need to pop it until we get the lesser element. Yeah, I think this should be greater only. Yeah, this should be greater. See, guys, just about the arrows, and here we have to check what lesser. Correct. Let's see. I'm thinking this time it should work. Let's see. Yeah, -1, 2, 2, -1. That was our answer. -1, 2, 2, -1. So guys, it was just about the arrows, and we find it out the next lower element to the right. It was just about the arrows. I was just missing some of the arrows, which I only get to know with the visualization. That's why I was saying the visualization is very important here. And you can see same code has given you the different result. Everyone agrees with that? Everyone agrees? Yes, we'll do from the left also. We'll do from the left, but I will tell you that those are the next 2 scenarios. Guys, now we only left 2 scenarios where we need to find greater element from the left side and the lowest element from the left side. Everything is same. Everything is same. Just we need to change the loop. Can you show code why you got 1, -1, 2, 2, -1? Yeah, this is the code, right? Same thing, Likit. We just change the arrows there. We just change the arrows. So earlier we were looking for the greater element. This time we are looking for the lower element. So see, once our stack element is lower, so we will simply push it. You can see once our stack element is lower, you can see it is lower than the current element. Once our stack element is lower, we'll simply push it. Earlier what we were doing, once our stack element is greater, we'll simply push it. Correct? Now, once our in the slower scenario, once our stack element is not slower, when our stack element is not lower, it means stack element is greater. So we need to do the popping. We need to do the popping, and we need to do the popping till we got stack length greater than 0 or stack जितने भी elements हैं वो greater हैं. Whatever elements are in the stack, if they are greater than the current element, we need to simply do the popping because we are looking for the lower element. Okay, and once we done the popping out here, we will simply look, is still there is any element in the stack? If yes, if no, then simply push -1. If yes, then check that element should be lesser than the current element. You can see the stack element is lesser than that, and then we pushed it. See, now I also remember it. Earlier I was forgetting it while explaining, but now I remember it. Actually, we only need to look in the stack one. You just need to look into the stack one. For greater, look for the top element in stack. For greater, look for the top element in stack. And for the smaller, look for the smaller element in stack. And based on that, put your condition. Yes, it's for lower element in the right. Guys, I've just given you one more clue here, which I got while explaining. You only need to look for a stack. Whatever the top element is the stack. If you are solving problem for greater element, so always your stack top element should be greater than the current element, If your stack top element is not greater than the current element, you need to do the popping till you got the greater element, or stack dot length is equal to 0. Understood? It's basically similar just comparison with the top element is reserved. Yes, we are just simply doing the comparison with top element every time. In the stack, whatever the top element, we are simply doing the comparison. So Joseph was asking, can we do it from left? So yes, we'll do it also from the left. And then he's saying, but why wrong answer? Which one, Joseph? Which wrong answer you're talking about? We got the correct answer, right? -1, 2, 2, -1. This is the answer which is matching with us. You see, -1, 2, 2, -1. That's what we were looking for. And then push and pop accordingly. Yes. So we are, see, but showing wrong. Oh, no. This is not, we are not solving this problem. Joseph and Suraj, whoever is asking these questions, I think, I'm not sure Suraj has also asked, but somebody has also asked it earlier. We are not solving this problem. We are solving our scenarios. Okay, we are not solving this problem. Okay, guys? And then push and pop accordingly. Yes. Let's see, meanwhile, let's look Likhit doubts also. And got this. Okay, great, got this. So guys, let's quickly, so are we good with the two problems which we solved? Next greater element, next lower element. Are we okay with that? Yeah. Now let's look for previous greater element or previous lower element. Previous greater element or previous lower element. Sometimes we say that left lower element, left greater element. Let's look for that also. No change, same code, guys. Same code will work. So let's look for the same. Let's take the same problem. 1, 3, 4, 2. This time we are looking for left side. This time we are looking for left side. So let's start with left greater element. Left greater element. We can write LGE, left greater element. So you tell me, for 1, always -1. Correct? There is no greater element. So -1. For 3, no greater element. For 4, 3 is the 4. For 4 also, no greater element. I think for this scenario, for 2, 4 is there. Everyone agrees with the left greater element? You guys tell me, everyone agrees with left greater element? Anyone confused? Any confusion here? Let's also calculate left lower element. Left lower element for the same problem. So for first element always -1, क्योंकि उसके आगे कुछ है ही नहीं. For 3, the left lower element is 1. For 4, left lower element is 3. For 2, left lower element is 1. First left lower element. Guys, just calculate it. I calculated it. You also calculated it in your mind and check if it is correct. Left greater element, left lower element. Done it? Everyone agrees? Looks good? Everyone? I want response from everyone. Likit, you were confused somewhere. You have given -133 -1 for I'm not sure for which one. Yeah, yeah, I know. See, this thing will come with practice only. This thing will come with practice. I also sometimes look for right, look for left. So this will come with practice. But you see, one code is going to solve all 4 problems, and all these 4 problems are going to solve many problems. All these 4 problems: left greater, left smaller, right greater, right smaller. These 4 scenarios are going to solve a lot of problems. I will, like, whatever we are going to discuss next problems, only everywhere we are going to apply these 4 solutions. So yes, sir, now I am confused. Yes, tell me, what is your confusion, Deepak? Okay, let me first draw, let me write here also, right greater element. So everything will be at same place, and right lowest element. So you guys tell me, right lower element for 1, right lowest element, nothing, it's -1. Right lower element. Look for 3. 3 it would be 2. Right lower element. Right side, guys, look for right side. For 4 it is 2. For 2 it is -1. Okay, let's look for right greater element. For 1, first greater element is 3. Look for 3, it's 4. 4, there is nothing, -1. These are the 4 arrays which we have calculated. Correct, guys? With just small changes. We'll talk about these changes, but first you tell me, these 4 arrays looks good to you guys or not? This 4 array looks good to everyone. Let's spend some time. Okay, everyone now okay? Yeah, Deepak, you have to write your question about the 4th scenario. You can see these are the 4 scenarios, right, Deepak? Left greater element, left right element, left everywhere it is first. Everywhere left first greater element, left first smaller element, right first greater element, right first smaller element. Okay, guys? Okay, now let's solve the left greater one also. So I think what code we have written right now. This is, I think, this one, right? Left lower element, right lower element. Right, guys? -1 to 2 -1. So we just need to change, guys, here in this condition, nothing else. I is equal to 0. I less than array dot length. This time we will start from this side, and I plus plus. I think we do not need to change anything else here. But let's see our answer now. Let's see our answer. This time it should start from left side. Let's see our answer if we are missing anywhere. So array, oh, why I'm writing array? It should be nums2. Okay, 1 3 1 -1. Something is wrong, I think. Huh? We are looking for this one, right? Lowest. Yeah, 1 3 1 -1. It is giving wrong. Okay, so let's see. So we are starting from 0. We have calculated everything right correctly, right side, right everyone. So for 1, so left lowest element would be -1. For 3, it would be 1, right? For 4, it would be 3, right? And for 2, it would be 1. Yeah, correct, guys? This 4 array are correct, right? Oh, okay, okay. I have not. Answer is coming in reverse order. Okay, okay, okay. Yes, yes, yes. Sit, sit, sit. Yeah, I forget to tell this thing to you. When we are doing it from the left side, we do not need to reverse it. We do not need to reverse our answer. Yes, -1, 1, 3, 1. Totally agree. Now for this thing, the earlier code, we need to look for greater. So now if it is a greater, I am okay. Okay. Now if it is this, if it is not a greater, look for lesser, right? And look for greater here, right? And stack is this element. We have to continuously pop it until we got the until we got the greater element, right? So yeah, we need to do the lesser here. Yeah, until we got the lesser element, we need to pop it. Yes, yes. This should also work. So -1, 4. You guys can see these 4 are all 4 we got it. So what are the everyone understood? All 4. So now let me write it at one place. What are the changes we need to do? For 4, I have also written in my copy actually. You guys won't believe I have written in my copy. I remember in this way only. So let me write it also somewhere in a new page. Okay. So guys, there are 4 scenarios. Let's. I also written it in similar way. You guys can also create yours. You guys can also create yours similar like diagram. Okay. So first thing, next first greater element. Always remember these are all next first greater element. Okay. Uh, yeah, next first greater element. Then we have previous. Next का opposite क्या है? Previous. So previous first greater element or left greater element. Sometimes we say left greater element. Sometimes we say right greater element. Or again, first is already there. Again, now here for come for lower one. Next first lower element or right lower element. Again, right here also. Uh, Previous first lower element slash left lower element. Okay, what are the changes we need to do? In the next greater element, loop start from end. Loop start from end. Wherever right is coming, loop start from end. Loop start from end. Correct? In the in the left scenario, loop loop start from zeroth index. Start from zeroth index. Same here. Loop start from zeroth index. Zeroth index. Again, second thing to remember, we need to reverse the answer. Reverse the answer. Reverse the answer. अब देखो इन दोनों में सिमिलरिटी, कोड बिल्कुल सिमिलर है, बस ये चीजों का चेंजेस है. अब देखो इसमें भी कोड बिल्कुल सेम है, सेम कोड, just little changes. अब now let's talk about code changes in these two, because here both ways code same, it's just the looping part change. Here also code same. अब इन दोनों में कोड में क्या डिफरेंस है? Here and here. No, no, no. Wait, 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 wait. I just written a little bit wrong. 1 minute. 1 minute, guys. Greater का कोड सेम है. ये दोनों कोड सेम है actually. Greater code is same. Code is same here. This code is same. Same here also. Code is same. Difference is in greater and lower. Difference is in greater and lower. So let's write that also. Greater and lower. Okay. Greater and lower. Let's write that also. In the greater, always look for stack top element, and that top element should be greater. That top element should be greater than the current element. If yes, push it. If yes, push it. Else, do the popping. Do the popping with proper conditioning. With proper conditioning. Guys, remember it like this. Same here. Always look for same stack top element, and that top element should be lesser than the current element. If yes, push it. Else, do the popping with proper conditioning. Guys, that's what you guys to also write it. You guys also write it in your one place if you want to be, because this is going to solve a lot of problems. Stack and this approach is going to solve a lot of problems. Definitely these are dadi maa ke nuske. Definitely these nuske are going to help you. अभी देखो इसमें देखो guys, if you guys are already 15 minutes is over, if you guys see after there is like after there two more problems are there. I think this problem is very easy. Second one, where we have to remove the duplicate element from the adjacent, which is very easy. But after that, whatever problems are coming, you know, this one, sum of sub array minimums, same four methods are going to use. Sum of sub array minimums. After that, stock span problem, same methods are going to use. Same these four methods. Maximum area histogram, same methods, guys. Same these four methods are going to use. Then there is one more is there. Maximum rectangle in the binary matrix. Same four methods are going to use. So that's why, guys, and you know, the maximum histogram or maximum rectangle, these are a Google question actually. And they have only this approach or DP, dynamic programming. Sometimes they go with the dynamic programming. But yes, if you know these four approaches, these and you know the code of these four approaches, these problem will not be difficult for you. You will solve this hard problem in minutes. So okay, guys. So that's all from today, and I will take the screenshot of it and share in the LinkedIn, so you guys can take it from there. But I will say that you guys practice it and write it in your way, as I have written in my copy also. Okay, everyone. So that's all from today. I hope you enjoyed it. In next class, we are going to look for the next stack problem. I'm going to tell to Anshul that we need one more class to understand stack problems. Okay. Then we'll have our next class in stack problem. But before that, practices. What is H/W? Oh, it was written somewhere. Where it was? Homework. Ah, homework is stock span problem and practice all these four patterns. So guys, homework for you, everyone is that first practice all these four problems, because I have explained it. But you have to do practice, right? You have to visualize it. Once you will do that, then only you can visualize it. And I will say to everyone, whoever is doing the older things, please keep those things little bit like for later time. First, solve these problems. First, solve these four problems. Write your code, share it in the LinkedIn. Okay, and then after that, if you have done this, go for a stock span problem. Stock span problem. You will got in a lead code. Stock span problem. Everyone got the homework now? Relevant test round is tough. Round 2 is tough. Acha. Deepak is saying no. So Deepak, listen. First you have to do the practice. Whatever we have done in today's class, all four problems. Okay. Next greater element, next lowest element, then previous greater element and previous lowest element. First do all these four problems, visualize it properly, then write the nuske or the mantra which we have written it today. Once you are like fully familiar with that, then go for this problem, stock span problem, and share whatever you are doing, share it in the LinkedIn also, in that group, so everyone can also see it. Okay guys, so that's all from today. I hope you enjoyed it. So we'll connect back in our next class. Bye bye. Good night. Thank you. Thank you, everyone. Bye bye.